Okay, hello everyone. Welcome to the SQL week project. So in this week, we're going to be looking at SQL projects. I will be getting this from LinkedIn. It's just a list of projects that we're going to work on. And the goal of this session is to go back to the concept of creating databases, creating tables, and also inserting data into those tables. And you're going to see questions will follow later on. But we have to first of all build a database which will host the different tables, and then we also have to insert the data into these tables. So today the focus is going to be on the create statement. That's what we're going to use to create databases, maybe schemas, tables, and also the insert statement, which is what we're going to use to insert data into tables. All right, I'm going to go back to a lecture material we had. Probably, I think that should be in the first week. Let me check on day 1, day 2. So it's something we skipped. I just want us to go back to, I think it's database fundamentals. Let's see this one. So this week, this one right here, week 1, 2, and 3 lecture notes. So there's a segment I skipped which has to do with creating databases, creating tables. So let's go all the way to the beginning on this. Yes, we're going to visit these data types. I'm going to show you how to state the column and then specify the type of data, and also columns have constraints as well. So we're going to be going over these constraints right here. Yes, so this right here, creating database objects. So how do you create a database? So this is the code right here. So if you just go to Google, SQL code to create a database, you're going to see something like this. Right. And this is where I want us to begin. So we're going to be working on this project, on this PDF document right here. So you receive 2 PDF documents for the session of today. This under SQL projects as a new folder. So we have the North Star one, and we have the SQL notes. Right. Let me just go ahead and open both of them. So I have the North Star one, which is this one, the main project, and I have this SQL notes right here. And if you notice this, they started off by creating database. There's the same code right here. Create a database, you specify the name of the database you want to create. And this is what we use to connect to the database. So once you create a database, you connect to it, and then you can proceed creating tables. So this is exactly what I want us to do, right? So we're going to focus on the North Star one. The codes, you can use this to look up the codes, or you can also use the PDF document, the lecture materials for week 1, 2, and 3. This document right here. So it shows you how to create a database. There's a code right there. It shows you how to create a schema, right? And then it shows you how the basic framework on how to create a table. So we're going to begin with the very first one. Top on the hierarchy is a database. So how do you create a database in SQL Server? Right. So the link I forgot to attach yesterday, the link will help you to build a database using the graphical user interface. So there are 2 ways to build things in SQL, right? So you can build a database without running any code. You can just right click on the database folder. I will encourage everyone to watch that video, new database, and you simply state the name of the database you want to build. See? But in this session, that's what you will see in that video. I encourage everyone to watch that video. If you want to create a table, you just simply expand. I want to create a table, for example, inside Academy database. I'll just expand, go to the tables folder, right click, new table, and this environment will pop up, and you start typing the names of the column. Every column must have a name, specify the data type, and you put some constraints. You see that? So, but the version I want us to study today is the much more recommended one, which is goes through coding. Right. So I want us to open a new query window. Right. We're going to start by creating a database called North Star. So the North Star database is going to host this project. It will have two tables, department and employee. So that's the first thing I want us to do. Right. So go to your management studio, open a new query window, and just type this code create. That's the instruction you're giving. You want to create, what do you want to create? I want to create a database. Now, what is the name of the database? Every database must have a name, right? Not star. Let's make that one word. So this is an instruction telling the database you want to create, telling the database engine you want to create a database. So create database, and the name of the database is not star, right? And now we can put this on a separate window before we go to the next step. So once you create a database, you can now connect to it. You see, let me do it one after the other. Let's stay right here. Please, when you type this, just go ahead and execute. So when you type that, just go ahead and execute. All right, so I'm going to just highlight and run execute right here. And this is what we have. So once you have this outcome, command completed successfully, it means that this code ran successfully. What was the goal of this code? It was to create a database called Northstar. Now we can go to the databases folder and we refresh it. Now we should be able to expand on it, and you see a database called Northstar. This is it right here. So this is the code. This carries an instruction telling the database engine, go ahead and create a database called Northstar. And since what we created is a database, we cannot find it in databases folder. And this is it right here. Right. This is a script we're going to save. So I want to encourage everyone to go ahead and just click on the save button. The things we're going to be typing on the script, we have to keep saving them. So this is a Northstar database script, right? You can just provide a name. You can easily, descriptive name basically. So this is a Northstar. Please, if you run into any issues, just let me know. Northstar database script is already a good start. And make sure you save it in a location you can remember. I'm just going to go to my class folder. I basically created a new project, a new folder called SQL projects, which is going to carry the materials for this week. Right, so I'm going to save this is SQL file. I'm going to save it, so it is saved in that folder. Right. So this is proof that the Northstar database has been created. It's right here. Right, now we can go to the next line. If you look at right here, we are still on master. Right, we need to have Northstar database right here so that we can proceed to create the department and the employee tables. This is very important. So once you create a database, by default, the system will always have it connected to master. It is your responsibility to switch it. And if you look at this, this sample right here, once the sample 2 database has been created, you see what they did? They connected to it before proceeding to create the customer table. See that? So you have to understand that tables are hosted within databases. So once you create a database, you must make sure that you're pointing to the database you just created, so that the next or the subsequent steps, like creating tables, will go to the database. If I proceed to create a table right here, it will be created in the master database. And that's the error most students experience. Right. Once you create a table, it will be created against the database you have right here. Right. So it's important that we just switch this to Northstar. So the focus is now on Northstar. You see, I can pull it up. It's not showing right here. Right. And I'm also going to put a go so that it's on separate batch. I think last time I did mention this, and just distract you guys a little bit. You cannot create a database and connect to it on the same script. So if you try doing this, I want to create a database. This is just an example. I want to create a database called ABC. Right. And then on the same stuff, I try to connect to ABC. Right. These are 2 steps that are like prerequisites. This one is needed for this one to come in. See, so you cannot run this on the same batch. how do you know commands are run on different batch when you have a goal separating them? So this is what we call a batch terminator, right? It places them on separate batch. You cannot run these two at the same time. See, without a goal, these two commands will be executed exactly the same time. Right, so if I run this, you see I get an error. Database ABC does not exist. So the ABC database needs to be created first before we can connect to it. So these two, they have to be run one after the other. And that concept is understood better when you do this. You see, although you're going to run them at the same time, but the system will process this first because it's on a separate batch, followed by this. And that's how you're able now to execute this. You see that? So you see me, I'm trying to separate the commands because the goal is you build a database for a company, you're going to leave them with this script. This is the script you submit at the end of the project. The company will own this script. Right? So you want to arrange the commands in such a way that they execute without any error. So those steps that are prerequisites for others, we need to make sure we place them on separate batches. This is very important. You don't want to submit the script at the end of a project and you have something like this going on. And when they try to execute it, they get an error. Right? So those steps that are prerequisites, always make sure that you place them on separate batches. Right? Okay, so that was just an explanation. Now let's go back to this. So this is very important. When you create a database, you want to connect to it. Right? You have to execute this. So you see that the focus is now on the North Star database. Now we can proceed to create tables and it will be created against the North Star database. This is very important, right? Any questions so far? Please, if you have any questions, just stop me so we can. So you have to understand what these two commands are doing. This one is creating a database called North Star. We've been able to show proof that the database was created. This is it right here. The next command, we are familiar with this. This is connecting to the database we just created. So we have it flagged right here. So it means that if we can now engage this project by first of all creating the department table, right? And then next we follow that up by creating the employee table. Right? So a quick review on the statement that is used to, I'm going to skip this part, the schema. If you want to put this on a schema, I'm going to show you on a different project. We're just going to run create schema and we put the name of the schema, right? So I'm going to skip and go to table, right? And it's always also good to put instructions creating the North Star database. For example, this right here, you can just put as a comment so you understand what each step is doing, creating the North Star database. I will always encourage you to add comments to your codes, explanations, right? So creating the North Star database. This is the comment and this is the actual creation of it. So what are we doing in this step? We are actually connecting to the Northwind database script. Connecting to the Northwind, the North Star database. This is the goal of this step right here. All right, so always, include comments or explanations on your script, right? It will help you down the line, right? So we've done this part, right? The next thing we're gonna do is create the first table. Per this project, the first table is the department table, right? And I'm going to give you a guideline. When creating tables, start by creating the table with no foreign key. I'm going to bring in a concept right now so we can understand it. So I'm going to go back to these definitions right here. And the very first one we're going to talk about is primary key. The primary key uniquely identifies each row or record in a table, right? This is something that should be unique for every entry into a table. For example, in the North Startup project, we are looking at department. That's the department table. The department table is going to contain the following columns: department number, name, and location. Every department must have a unique number. You see, no two departments will have this same department number. You see, and so when you identify a column that should contain unique information, it is best practice to set that column as a primary key. So a primary key is simply a unique identifier. If I put where department number equal to 10, that is the accounting department, no more. No two departments should have that. So if you're trying to insert a new department into in the future and you assign that department number to 40, the system will give you an error because 40 is already assigned to the operations department. This is very important. So a primary key is simply a column in a table which is built such that it will uniquely identify each row in that table. For example, no two cars have the same number plate, same VIN number. Those are primary keys. You see, same thing like the student ID, employee ID. In the US, they have the social security number. Right? No two US citizen or permanent resident have that same number. Right? Those are key candidates when defining a primary key. Right? So that is very, very important. Right? Okay, Idris is just joining. Okay, Lane, let's wait for Lanita is going to join. Let's just take over this explanation again. So Lane and Idris, you all welcome. Is Lanita going to be joining? Is my volume okay?
Yeah, your volume is fine, Mr. Bless.
Okay, good job. Okay, so Lanita just arrived. Okay, so I'm going to repeat this process again so we are all on the same page. So you all welcome everyone. This week we're going to be working on projects, right? I'm going to show you a sample project we're going to focus on. I did send this in the email, so we have the North Star project, and this is something I got from LinkedIn. This is a sample. This is a project right here, right? So in this project, we're going to be building a database, build a table, two tables to be precise, department and employee table, and then we're going to proceed to insert data into these tables. You see, these rows of data will be added. These ones will also be added. And then once you're done, that's phase one. Phase two will now start solving questions based on what we've built. See that? So this is a part I skipped at the very beginning of the training. And you can go back to the lecture materials for I got this from that should be week 2 or no week 1 day 2. You're gonna see this file right here, week 1 day 2 lecture notes, and it is gonna bring you to this. So I'm going back to the very beginning to address some key concepts we missed out. I'm going to talk about SQL constraints. I'm going to talk about data types, right? So when you build a column, every column must have a data type. I think you're familiar with that concept. And these are the different constraints we're going to go through. And so this is where we started today. How do you create a database in SQL Server Management Studio? The first video I sent out yesterday, I actually forgot to attach the link. I got a reminder from Alex. So I'll encourage everyone to go back to that email. I attached the link. Just watch that. There are 2 ways you can create things in SQL. The first one is what we call the interface approach, where you just have to right click. If I right click on the database, it means I want to create a new database. You see? And once I have that set up, I can just put the name of the database I want to create and click on OK. Okay, it's going to create it. Right. So that aspect of it does not need coding. That's the interface approach. You're simply interacting with the interface of SQL Server Management Studio to create objects, right? So that's what you're going to see in that video. I encourage everyone to watch that video. So in this segment, I'll focus more on the coding strategy, you see, right? In the coding, you will have to write the code, right? And that's where we've started today. For those who just joined in, this is the part you've missed. So I'm going to repeat this. We are working on this North Star project, and we've started off by creating a database which will host the two tables we're going to create in this department and employee. So you have to understand that tables go into databases. The hierarchy is server. Once you're connected to a server, you see the databases in that server. So once we're connected to the server, we want to build a database which will host the North Star project, which will have the department and the employee tables. So this is very important. So that's the first thing we're doing right here. So this is a comment just telling us we're creating the North Star database, and this is the SQL code behind creating a database called North Star. Let me just share this with those who are just joining, so we can have this, and the next will be hands-on. Whatever I type on my screen, you understand it, and then you do it on your screen as well. So please, before you execute something, make sure you understand what we're doing, right? So I will make sure I add explanations, to single line of explanation at the very top of any code, so you understand what that particular line of code is doing. So this is the code to create a database in SQL Server. You just simply give the instruction create, and you put the type of object you want to create. It's a database. If we're creating a table, we're going to put table right here. If we're creating a schema, you're going to put schema right here. I think we have that. See, if I go back to this lecture materials, this is to create a database. If we look at this one, it's the same create, but it is pointing to a schema. And then next is the same create statement, but it's pointing to a table, right? So we're gradually going to explore all of those. So first, we are looking at the database. That's the main container that will host the tables and schemas and stuff like that. So this is a line of code you're going to use to create a database called North Star. So I want you to highlight this for those who just joined and execute, right? And you notice that it will create a database called North Star. Once you create a database, how do you show evidence that it was created? You simply go to the databases folder and refresh it. And if you expand on it, you just go alphabetical order. N is going to be after M, it's right here, North Star. So this is an instruction that tells database engine, go ahead and create a database called North Star. Every database must have a name, and you must disclose the type of object you want to create. Are you creating a database? Are you creating a schema? Are you creating a table? Right, so this create is not enough. You have to put the keyword database, and remember that every database has a name, and that's the name of this particular database we're trying to create, right? And then you see this next one right here. It tells you, if you look at, once you've created a North Star, if you look at this portion right here, it is pointing to master or any database you've worked on previously. So it is always a good practice that when you create a database, you connect to it. So this is, I think we are familiar with this code. So we've been using this each time we have a project, you want to work on the database, you first of all connect to the database in question. So we are familiar with this one. So this connects to the Northwind database. And after executing that, you're going to see it flagged right here, right? Please remember, once you've created a database, you cannot go back and run the code to create it again. You're going to get an error because the database already exists. So no two databases can exist with the same name while residing on the same server. If it's a different server, that's fine. But as long as it's the same server, you cannot have two databases with the same name on the same server, you see. So as we proceed, the code we're going to be adding to the script, that's the one we're going to be executing. So at no moment should anyone just go run execute without highlighting the portion you want to run, you see. And the last thing you guys missed, you just have to save the script. We're going to keep building the script, right? Make sure you click on the save button, right? And this is going to, if you're doing this for the first time, it's going to pop up, and you can now provide the name of the script. in my case, I just called it the North Star database script. So we're going to first of all build the database, and then just go into solving the equation. All right. So Lane, Idris, Lanita, any question? So this is what I expect from you. You must have if you've executed these 2 lines of code, you should have the North Star database created. You'll be able to see it right here. If you don't see it immediately, you can refresh the databases folder, and then you should be able to see. This is what I just created. I'm going to delete it. Right, so you should be able to see North Star right here. And then second, make sure that when you go back to the editor, you should be able to see North Star. This shows that this code was executed. This is proof that this code was executed. This is a proof right here. See? Right. Okay. If you're all ready, we can move to the next aspect. I'm going to skip the schema part. We're going to come back on schemas for a different project. But it's easy. You just put the same create statement, put the name of the schema. So in this project, I want all our tables to go into the DBO. The DBO schema already exists, a default schema. All right. So the next step of this project in the North Star, we're going to create the department table. All right. So I'll always begin by putting the comment. Right. So creating department table. And we want this to be in the DBO schema. So right. So that's where this table is going to reside, in the DBO schema. Right. Now let's review this code right here, this instruction. Right. Even if you go to Google how to create a table in SQL, same thing. All right, let's just do a basic search. At this point, you have to make it a habit to go to the internet and search. All right, this is very, very important. So how to create a table in SQL or SQL Server. Right. You can check out this one. I want to see. I see W3 Schools right here. It's a website we are familiar with. All right, this is it. This is pretty much where I got the codes to create this. We just created a database. You see, create a database. The syntax is right here. Create database, the name of the database. Now we're creating a table. The syntax is right here. To create a table, same thing. Create table. You put the name of the table. Right. You have to understand that this is not enough to create a table. Why? Because tables have columns. So this extension addresses that part. You have to understand that the code to create a database is easy. Right, this is it. Create database, name of database. The code to create a schema is very easy and straight to the point. That's it right there. But then the code to create a table is much more expanded, in the sense that tables contain columns, and each column has to have a name, a data type, and then constraints. And once you're done with that particular column, you put a comma and you go to the next column. So if you have 50 columns, you have to define each of them 50 times. You see that? So that you have to understand the expanded nature of the table syntax. Right? And this is very, very important, because it's always going to be a problem if you just put create table. We want this table to go into the DBO schema. So I'm going to put DBO dot, what's the name of the table? Best practice, always follow the information as provided by the company. So it's a department table. We're going to abbreviate that as seen in that document. See? So if I stop right here and I click on execute, I want you to understand why we have an error, because the syntax for the create table statement is not complete. A table is complete when it has columns. And then from the columns, we're going to add the rows. That's the insert statement. So the system splits the two parts. creation of the table, we are focusing on the columns. Then next, we go into the insert statement. We bring in the rows or the actual data into the table. Right. So you have to understand why this right here is a serious error, because you haven't included the columns. Every table, a table cannot be empty. A table needs to have columns. Right. You see, so now I'm happy we can understand this. See, previously I used to teach this before we go into the select statement, and students do not really understand. But this is the best way to teach SQL. You address the select statement and every other thing, and then the last week of the training, you take them back to the create statement. It's going to be much to the create and insert statement, right? You see other statements, it's going to be much more easy. So now you understand this concept. The department table we're trying to create will reside in the DBO schema. All right, you see that? And then next, this is very important. We add the environment, which will use to define the columns of this table. See, so now everything falls into place as far as the syntax is concerned. See that? And now there's a typical creation of a table called persons with the following columns and data type. So every column must have a name and capture data of a particular type. Very, very important. You see at the end, you see, close the parenthesis. So the parenthesis is the environment to define the columns. And this is very important. So once you go back and watch those videos, if you want to create a table in the interface approach, you simply right click on table, you go to new table. This is what you will learn in that video. Every column must have a name. This is where you type the name. Data type is where you put the data type, and then we just call this generally constraints. I'm going to address that part. Right. So I will encourage everyone to watch that video. Right. But then this is the main part. You should be flexible on how to create things with coding option. Right. So this is a framework right here. Very, very important. I want to do it gradually so that we understand it. And so once we have that framework, let's take a deeper dive in it. So the first column information goes right here. Basic information for every column. Every column must have a name and every column must have a data type. These two are mandatory. Right. These ones are just things we add, extra things we set up on the column. But from a very basic perspective, every column must have a name and capture data of a particular type. You see that? So if we go back to the North Star project, let's start targeting the columns. The very first column is what? The department number. And I will just do my best. Let's stick to the names of the columns as provided in the project. Right. So easy, you can just copy that name. That's the first column. Alternatively, we can copy, and let's do one at a time. Let's copy the first column. I really want you to see how this is built. So every column must have a name. That's the name of that column. No comma, you go to the next. Every column must have a data type. So I'm consulting the syntax so that you understand. This is the name of the column, data type. Now to specify the data type, you have to go back to the project and get a full picture of the table. These are what? These are numbers. You see? And usually you must have sat down with the business so that they guarantee you that, okay, department numbers will be stored as numbers. At no point should we have letters, maybe 10T or 10, 20R or 30S. See, as long as you guarantee that departments will be numbers, you can now set integer right here as the data type for the department. You see that the moment I set integer, that error goes away. It just tells you that there's a problem right here. The definition for column must include a data type. And that's why I highlighted that these two are mandatory. Anytime you're building a table, you state a column mandatory, data type mandatory. You see? So this is it, integer. So that's, I can stop right here and that column is good to go. Right. Every column must have a name and a data type. This is non-negotiable when creating a table. See? So I want you to understand, your goal is to understand every line and why this extension. I just talked about that. That extension is because columns needs to be part of the table definition. Just defining like this is not enough. You're going to get an error, right? So, and how do you start bringing the columns? You must put them in a set of parentheses, list them one after the other. See, but there are some extra things I want us to do on this department number, and that's when the business side comes in. Every department must have a unique number. So that's where the constraint comes in. So this, we just bundle this and call constraint. And in the lecture material, you're going to see constraints, different constraints right here. This is what we all call constraints. Constraints are rules, they are conditions, they are guidelines you set on a table, and those conditions must be respected. So no two departments should have the same department ID. That is a business rule. I want to enforce it on the department number. If not, you're going to have confusion. Somebody will come and insert a new department and assign it to 40. 40 is already assigned to the operations department. So no department should take the value 40 moving forward because that's already been assigned to operation. And to do that, you have to make it a unique constraint, or you make it a primary key constraint. These are two constraints right here. These two combined define the primary. So first business question you can ask: every department must have a department ID, true or false? The business will tell you yes. Every department in a company must have a department number. Okay, so that's the concept of what? Not null. This right here. A not null constraint simply ensures that a column cannot have a null value. In basic English, this is what? Mandatory column. So every entry must, every row you add to the table must have a value for that column. If you're adding a new department to this table, that department must have a department number, right? That's what the not null is enforcing. It's a mandatory column. The next, which also goes together, is unique. Ensures that all values in a column are different. Should every department have a unique or a different department number? The business will tell you, yes, we want that. So instead of defining these two conditions separate, this and this, right, I'll just go ahead and put primary key, because when I put primary key, it covers these two conditions, right? So instead of doing this, put not null. That's all you just have to put. There's no magic to it. Not null and then unique. Instead of putting these two conditions like this, you see, these are constraints. Please don't comma separate them. The comma comes at the very end. So instead of defining like this, we just dismiss these two and we put the keyword primary key. All right, this will take care of those two conditions. When you enforce the please remember we are now looking at constraints. Go back to our build up. We have constraints. Every column must have a name, carries data type, and then constraint. And what are the constraints available? These are them. All right, so primary key enforces these two constraints, not null and unique. So it's a column that everyone must have that value, and the value must be unique or different for each. So you have to define this with respect to the table you're dealing with. We are dealing with what table? The department number, the department table, sorry. So we are looking at department number. Every department must have a number. That's what the business says. So that's the meaning of not null. Second, department numbers across the different departments must be different, must be unique. Right? So combining uniqueness and mandatory gives you the new concept called primary key. So when you put primary key, it enforces these two constraints. Right? And these are the characteristics. Cannot be null, it means that this has been implemented. Must be unique, that this has been implemented. Immutable, cannot change over time. Yes, you set a primary key on a column, that column should not change over time. You cannot set primary key on age. Age changes over time. Right? And two or more employees can have the same age, so it's a violation. For you to set a primary key on a column, they must meet these two criteria. Is a column unique? Right? Is a column not null? Everyone should have that value. And then also, very important, it should not change over time. Don't set a primary key on a concept or a metric that changes over time. And then this is also very important, only one primary key per table, right? So these are literally you can read. Now I'm done with this. So I have the column name, data type, constraint, and I can now put a comma right here and go to the next column. Please, let's build this gradually. So I want you to understand everything going on right here. This is the name of the column. We are working on the North Star project. This is the layout. The name of the column is department number. That's the first column we're starting with. And this column hosts what? Integers. These are whole numbers. Right? That's the instruction right here. Only whole numbers can be inserted into this column, department number. I don't want somebody to insert a department ID 10.5. It's not going to be allowed. Integers are whole numbers. This is what we call a constraint. It's a rule, it's a condition you're putting in place when defining a column. This column will have a primary key, right? And primary key simply enforces the two conditions above, not null and unique, right? Good job, you see. Now we put a comma and we can now go to the next column. We have to exhaust all the columns on that table. We are currently building the department table. The next one is the name, the department name, D name. I'm just going to copy that. I'm very lazy in typing. Just paste it right here. I want you to see the build up. Now, this is the name of the column. What is the data type? Go back to the project and then you look. These are strings. These are letters. Right? We can go for N VACA. Now, those data types come in N VACA. Right? This is one of the data types we use to capture strings. And then when you're storing integers, you don't put anything in the parentheses after the definition for numbers. But for strings, characters, letters, you must add something in parentheses. See? And what is that concept? It is the maximum number of characters that column can hold. So for example, if I put D name and a department name, you have to make sure that the number of characters for each department should not exceed the maximum you set in parentheses. Characters are what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The accounting department has 10 characters. You see, so you have to go for a number that will be sufficient across all the departments. If you try to insert a department name that is more than 50 characters long, the system will give you an error because the maximum we've set on that column is 50. So this is something that is used for strings only. You cannot set the number of characters when you're dealing with integers, numbers in general. So it gives you an error. Right, this is very, very important. See that? So when you set 50, it means that you cannot insert a department with more than 50 characters in its name. So it is always good to set a high value. Some people even go up to 100. Right? See that? Right? 50 should be okay. Right? So that's the data type is department name. Sorry, the column is department name. The data type is NVACA 50. That's a string. And what else do we have to put any constraints? Now, based on your conversation with the business, is department name a mandatory column? Should every department have a name? If the answer is yes, then you have to enforce not null. Every department must have a name. So we put null. The default is null. So if I don't set any constraint on this, the default will be null. But if I want the department name to be mandatory, I have to put the constraint not null. There's no magic. That's the only thing you type, not null. The system understands that every department must have a name. If you remove this, the default is not null. It means department name is optional. Right? So it depends on how the business wants. Of course, you're building this database for the business. They will set the rules and regulations, and you just enforce them. Right? So this is the second. I'm going to pause right here so that since we are doing this together. So I've set 2 already. And anyway, let me just go ahead and complete this, and then I'll pause, and you also have that completed. The last one is the location. Let's just go with the abbreviation, but I think we understand. I just want to make sure we capture the same information as in that document. You see that after every column, I put a comma, not after every of these entities. You see, you reserve the comma at the end of the line. It tells you now I'm going to the next column. That's the meaning of the comma. You see, so the next column is what? Location. Immediately I get an error because the definition of this must include the data type. Always remember that every column must have a name and a data type. Those two are non-negotiable. Again, we go back to the project. These are what? Locations, these are strings. See, we have New York, Dallas, Chicago, Boston. Yeah, we can use the same concept right here. Is there any location that will be more than 50 characters long? So it's basically a string, then that's it. I want you to see what will happen if you don't set the constraint not null. I will show you how this will behave. So we don't really care about the location. If the location is available, put it. If it's not available, still fine. So this is basically an optional column. So for an optional column, you have two ways to set it up. You can do null, or you can just remove and you just leave it blank. The system will apply the default, which is null. See? I want to stop right here and make sure, please, you understand every single line on this. Right? In understanding scripts from SQL perspective, you have to do a line-by-line evaluation. Do you understand what this is doing? This is an opening statement declaring that you want to create a table, right? And you're specifying where this table will be located as a schema. If I remove this, it will still go into the DB of the default schema. You see? So you have to understand this. This line needs to be understood. It is an opening statement telling the system, hey, I want to create a table. The name of this table will be department, abbreviated like this. And I want this table department to reside in the DBO schema. Excellent opening statement. Why do I need this part? Why is this not enough? I think I've explained this. Every table needs to be defined alongside its columns. And that environment goes into the parentheses, open and close. This is based on this project. We are not manufacturing these names. That's why everyone should have this PDF document in front, right on the screen. Right. In a company or advocate, they'll give you a monitor, 2, 3, as many as you want. This working document can be projected on one monitor, and then you type it on another monitor. Everything is in front of you on the screen. You have convenient working environment. So start training yourself how to use monitors. Right. Don't force yourself on a single screen on your laptop and you see, you're opening windows left and right. No, work like in a professional environment. Do with monitors. You see that? Right. So everything we are building, we are using this document. We are not creating or manufacturing things. You see that? This is a document from the business and they want you to implement it, right? That's why we are following the names exactly as they occur. Everything should be done exactly as the business has provided. Right. Okay, so this is the end of that process. You see, please remember the comma goes at the end. If you remove the comma or you forget the comma, it's a syntax violation. All right, you have to understand this. If you're done with that, just go ahead and execute. I'm just going to pause for a while. Okay, let's discover this. So please remember, these ones have already been executed. So we're just executing the additional parts of the script. All right, so in this execution, I'll have to highlight this part, right, and then go ahead and execute. All right, and so once we have this message, it's a successful execution, we feel happy. What have we just done right here? We've created a table, and this table was created in the North Star. Please make sure before you executed this, you were on North Star. If you're on any database, that's already a mistake. All right, so this was created against North Star. It means this table is available in the North Star database. So I'll have to go to my Object Explorer window and target the North Star database. Star right here. I have to refresh so that it updates, and then go to this to expand. Department is a table. You have to identify the correct folder. You're not going to go into views to find department. No, it's a table. It's a physical table. Expand. And we have it right here. See? And I'm not going to end right here. I want to take this further. You have to understand why the department table was created in the DBO schema. We specified it. Even if we did not specify it, we let it blank. It's the default schema. It will still go into the DBO. Right. Now, I want you to expand on that table and go to the columns. When defining a table, we specify columns. So let's see the columns folder. All right, now all of these things is making a lot of sense because we've gone through the most challenging route and we survived it. And now we are looking at basic stuff, right? But then basic stuff, but with some fine details added to it. Now everything begins to make sense. See that? Now the first thing I want you to see, why is there a key on this column and not on this one, not on this one? So the primary key column is identified by a key symbol together with the keyword PK. PK stands for primary key. So as you're prepping for your definitions in interviews, that's one key thing you have to remember. You have to know how to define a primary key. Set it in your own way that you can remember it and hold on to it. So from a physical point of view, right, in the Object Explorer window, the key symbol appears in front of the primary key column of the table. And it's followed by these things in parentheses. I'm going to introduce you to every single one of them so you understand. So PK means primary key. So this is the column we enforce as the primary key of that table. Second, what is this? Data type. And this is what we said. See, why did this pull up a not null? Because a primary key mandatory must be not null. It is not a question, it's not negotiable. Once you've set primary key on a column, the system automatically enforces a not null. Primary keys cannot be set on a null column. This is very important. Right, and that's why if you go back to these constraints, I bundled the first two, they're part of primary key. So when you set primary key constraint, automatically the column is not null, automatically is unique. See, this is very, very important. So these are the key things to learn. The key indicates primary key. This is data type. This is not null. If you go to the second, let me highlight the second column. Same thing, the name of the column as defined by us. You see, the data type was nvarchar with maximum number of characters set to 50. Same thing right there. And then we define this to be a not null column. This is a mandatory column. So nulls cannot be inserted into this. Every department must have a name. And then look at the interesting one, the last one right here, the location. We did not set any constraint on location. We defined the name, location, the data type, and then see what the system did. Right, null. If you do not define null or not null, the default is null. I wanted you to see this. That's why I could have done this as well. But I want you to see that when you remove this part, what will the system consider as the constraint? Null. Right. This side-by-side view is very, very important. Please, if you have any question, just I have to address it. This is very, very important. Right? Your goal is to make sure you understand this line by line so that at the end of the day, you can put it together and understand what this is doing. This is very, very important. See that? Any question before we go to the next? So this set table has been set up. And now in between, guess what? Yeah, you can run your select star from that table. The famous select star. Everything now begins to make sense. Select star from what? DBO dot department. And guess what? We have not inserted data into this table. So we're just going to have the column structure. See, the department number as first column, department name, second, and then third location, no data. So you have to understand the limitation of the create statement. It simply defines the structure of the table, the name of the table, the location, the schema, and then the columns. For you to bring in data into this table, that is a job of the insert statement. So the create statement is separate, the insert statement is separate. This is very, very important. So that's why in between I'm doing a select star from that table. So you see what we currently have in that table. We just have the column structure. Right. I want you guys to suppress this. Right. So in the database build process, you build the tables all first, then you move to in the insert part. Right. So I'm not going to go into inserting data into this table. I will go into creating the next table. But before we create the next table, I want us to do a simple exercise. If I ask you, this is Simit Clerk, what department is Simit Clerk working? This is department number 20. What is the name of that department? You have to take that number 20 and look it up so that Simit Clerk works for the research department. And you can do that for every other individual. James Clerk, this individual, that's an employee. Remember, this is an employee table. Right, so it's tracking specific information about the employees. For example, the employee number, the name of the employee, the job, right, the manager, that's the ID of the manager, the hire date, the salary, the commission, and the department number. So if I ask you, James works for which department, you have to go to the department number, right? This is a borrowed information. The primary table that is hosting that department number is the department table. So you have to take 30 and look it up in this. This is very, very important. So that's the sales department. You have to understand that Excel, which is a spreadsheet, is different from databases. Right? In Excel, we can bundle all of these two into one single spreadsheet. I stay on the same line. I know everything about I need to know about a certain employee. Their name, see the department number, and the next week I see the department name, the department location. All of it is spread on is put on one spreadsheet. That's what Excel does. But in databases, to get that relational management system, you have to spread out information. Every table is built to capture a specific set of information. If you're looking at the department table, you see only department level information, nothing more, nothing less. You see, when you go to the employee table, you see employee level information. We are not mixing them, you see, and then we can now create a relationship between these two. And now that gives you the idea of joins. If you want to join the department table to the employee table, how are you going to join them? They must have a relationship. That's the where the department number comes in. And this is what they call a foreign key. So a foreign key is basically, first, it is a primary key in its table of origin. But then it is residing on a foreign table. See that? I'm explaining this because we're going to be building the employee table and we have to set that reality. So when we build a department number, you see me putting the foreign key reference, and then I'm going to reference this table. So this is the parent table, and then this is going to be the child table. right? So any value you put in this column, department number, must exist in this column of the parent. So this originates from this. Take any single department number, you will trace it back to this. You cannot hire an employee and put them in a department that does not exist, a ghost department. See, our databases needs to be built accurately. You have to capture the business information accurately. This is the foundation of analytics. If you mess up databases, you will give a headache to the data analyst who will come later to analyze the data. Right? You have to understand that these are two separate processes. Next, we're going to go to the analytics. We'll start running queries against what we've built. So we have to build this nicely, consistently, accurately. Right? Don't put a department number in the employee table, which when we look it up, reference, we will not be able to see. This is very, very important. And that brings us the concept of a foreign key. Department number was considered a primary key as long as it's on department table. If department number finds itself on a foreign table, it becomes a foreign key. This table has its own primary key, which is this. Remember, no table can have two primary keys. See, this is also a key. We're going to make this a primary key. No two employees should have the same employee number. We have to set that condition. The same thing we did for department number. We're going to do it for employee number. Right? But then this is also a key. It is coming from a different table. So it's called a foreign key, FK. This is a primary key, PK. Right? So I want to set that so you understand. Be careful with the foreign key column. Any value inset on this column must be in the parent table. This is the child, this is the parent. That connection must be preserved. That's what we call referential integrity. It's the same thing in job verification. When you have a job offer, they're going to go through your resume and call the companies you work for. And the companies you work for will validate that information. Yes, Idris worked at MTN Cameroon from this to this period. That is your job verification. This is very, very important. It's the same thing. This person right here, Smith, is working for this company, sorry, for this department. If I take this department, number 20, I look it up on the department table. This is my source of truth. I see 20 years research. See? So you now understand that why the foreign key can have duplicates, multiple. See? Primary key can never have duplicates. This is an interview question. What's the difference between a primary key and a foreign key? You're going to get to that. I just want you to see this build up. So now let's target the employee table and build it. All right, forget about the records for now. We're going to insert later on. So let's set the environment for that. So usually if this area is not useful, you want more space, always important. You can just put it to the side. It's right there. If you need it, you pin it back. But to create more space, or you can just push it like this. So you have more space. See, that's how you work in a nice and conducive environment. I'm lazy in typing, so I'm just going to copy the same line of code and just modify it. We are moving now to creating what? We are creating the employee table. So creating employee table, still in the DBO schema. What will be the opening statement? Same thing we did above. Right. And the more you do this over and over and over, I'm going to give you a series of projects to work on. All of those LinkedIn stuff I was showing you, people build these projects and share on LinkedIn, and they're mostly Indian, very hardworking. We have to copy them. See, so create table. What's the name of this table? Go back to the project. Don't invent stuff. Work with what the company has provided. See, and usually when you copy something like that with a space in front, see, I'm having a hard time just isolating this. I'm just going to go ahead and type that. But I've looked at up the name. This will go into DBO, and this will be EMP, the code for employee table. This is not enough. You have to understand that table has built-in columns. A table cannot have no columns. It must have one or more columns. So how do you initiate the column environment? Always remember this. That's it. That's how you initiate that environment. And you go in and start typing the columns one after the other. Simple process, but then you have to understand what you're doing. What is the very first column? Is the employee number. I can just copy this, Control C. Or to make things easy, you can just copy the entire list of columns, Control C, and then you just paste it right here. And then you spread it. Every column should occupy a single. I don't know if this is going to be more confusing to you guys or you prefer this. At the end of the day, you can do, and you guys will become experts. You can do it in it. And I cannot go back and start providing every column must have a name. This is true. That's the name of the column. Data type, I can go back to the project and say, hey, data type, what am I looking at? These are things you can discuss with the project owners. I seem to see employee numbers are all integers. Are they going to be always integers? If the answer is yes, yes, I just go ahead and set integer right here. So moving forward, nobody can insert a string. For example, employee number BI50 or BI1000, those are not allowed. The moment you set this as integer, only whole numbers can be inserted into this column. So you don't just go ahead and do this as a database developer. You consult with the business. That is what we call business requirement gathering. When you sit down with the stakeholders and decide on a path to build a database. We are doing something very simple right here, but in companies, this can take an entire month. You have a series of business meetings and you guys, go back and forth on this concept. A skilled database developer will gather all these requirements to be across several sessions, meetings, right? And then come out with the document, and show it again to the company, they go through it and validate it before they will then sit and do what we're doing right here. So it's very, very interesting and also complicated process companies. You want to get it right, you see. Right. Maybe this is distracting. I prefer the one column at a time so that you understand. You focus on one column, you do the job and go to the next. I think that layout will be better. Right. So on this same thing, every column must have a name. We've looked up the data type. Right, or you can ask questions in those business meetings, set it up. Right. So next, we want to make this column a primary key. No two employees should have the same employee number. That's the meaning of unique, right? So when this is addressed. Second, every employee must have an employee number. This is the meaning of not null. So the combination of this and this generates what we call a primary key. So it's better to just type one key constraint, which will define two instead of typing the two. See that? So that's all you need to do. Set it primary key. It makes this column a primary key. No two employees will have the same employee number. Business rule checked. Second, every employee must have an employee number, and that constitutes the constraint primary key. Right. And of course, this primary key, what will be the nullability? It will be not null. It is a mandatory column. You don't need to go and define not null. Right. See people doing this. It's just redundancy. This is already implemented in this. There's no need to put this. You see that? Or you see people doing unique again as a constraint. These constraints are just words. Just type them. See? You see, both primary key and unique constraints have been defined for that column. You see, so it's already telling you this is a redundancy. All right, so kick this out. See, are we done with this? Yes, we have the name of the column, we have the data type, and we have the constraint. Put a comma and go to the next. Please pause and ask questions. You have to understand. I know I'm doing my best to explain this detailedly, but if you have issues, you have questions, make sure you ask so we can address them. Let's go back to the business requirement. We are done with this column. We've set up the name of the column. We've set up the data type, made it the primary key. The next column, I can just copy this one, Control C. Just looking at this, these are strings. You see, so the end varchar stuff will come in, and since names, yeah, we can just set end varchar 50. As any employee who will have more than 50 characters in their name, If that's not sufficient, you can push it to NVACA 100. So there's flexibility on this. You just have to make sure you're not, going for something like NVACA 10. It's possible that an employee has more than 10 characters in their name. So you want to set it to something higher, 50 or 100, that's fine. Every employee must have a name. Go to the sample table. It seems, yes, every employee has a name. That's a good business practice. Let's make sure every employee has a name. Yes, so what are we going to do? We have to define this as not null. This is mandatory. All mandatory columns carry the not null constraint. So a not null is a constraint that will ensure that every value in that column is provided. Right. So every employee's name must be provided. See? And that's it. That's how you go step by step. Go back to the requirement. We want to define the job column. I'm just looking also at the values. I see, yes, we can still do the same NVACA 100. So I go to the next line. That's a job name. This is NVACA 100. And I want to make this also mandatory. Every employee, we should know their name. We should also know their job. See, these are mandatory. See, what's the next one? This is the manager ID. Right. So I'm going to put manager right here. Remember, those are IDs. I'm going for an integer. Do all employees have a manager? I see a problem right here. This is the president. King is president. Employee name King. That's the president. They are answerable to no one. So the manager ID is missing. You cannot put a not null on this. This is very important. The system will give you an error when you're inserting data because there's one employee who is not assigned to any manager. In SQL, we call this a null. Right? So if you want to allow nulls to enter into a column, then the column must have the null constraint or just this. Last time we used blank, nothing was specified and we had null in this column. Let me show you now. You can add it null. So this or this is the same. So when nothing is specified, it's treated as a null column. If this is specified, of course, that's a null column. All right. So you see, I'm looking at the table to make those key constraints. Right. This is very, very important. I'm looking at this. It's clear that not all employees are assigned to managers. This is the president. Is answerable to no one. So there's no way you can go enforce a not null constraint on the manager column. We have to keep that an optional column. You see, if you have a manager, fine. If you don't have a manager, fine. That's the meaning of optional. See that? And the technical database language for that is a null column. So a not null column is a mandatory column, while a null column is an optional column. Right? I think that's sufficient for manager. Put a comma and go to the next. Right. Higher date. This is data type dates. You see, there's no time. If there was a time component, I'll put date time. So I'm going to put higher date and just follow it up with the date. Right. And usually, if the business will tell you it's not really necessary, if the person has no higher date, fine, it's higher date available. So we can just make this a null column. Right. Avoid enforcing not null. You might be shooting yourself on the leg. But then, of course, remember you have to consult the business so that they tell you what columns they consider important to the business, mandatory, and what other ones are optional. See, right? And you may be asking me, hey, is this a valid date format? Yes, we can check that. Can somebody give me a function that we can use? We've gone through the SQL journey, so I believe that you can work as a professional. You want to ask yourself, you're looking at this format and you're asking yourself, is this valid? Is this a valid date? What function can you use to test if a date is valid? I want to test this value. It's a date. I want to test it if it's valid. What function can I use?
is date.
Exactly. You just put the isDate function on that. And remember, the isDate function is an investigative function. So you're going to get 1 if it's a date or 0 if it's not a date. So you see how we can use that isDate function to do a simple investigation. And the fact that we have 1, it means that yes, this is a recognized date. So it is okay. We can proceed to insert this. So if we set this column as date, let me go back to this. It simply means only recognized dates will be inserted into this. That's why I went to show you proof that yes, these formats right here, they are dates. If not, we have to transform each and every one of them into a recognized date. But seeing that we've tested and the system has confirmed that yes, a date in this format is a date, this is good. Are we okay? This is the errors most companies do is they store date as a string. And that's where it's a problem, because if you type a funny date, you see somebody typing maybe this is the month of March 32nd. That's just a mistake. You see, it's a human error. But then if this is stored as a string, nvarchar, it will approve it. But if you store it as a date, only dates will enter this column. So if you do a human error, a typing error on a given date, it will reject it. You have to understand that these are constraints, right? Any attempt to violate the constraint, the system will reject that transaction, right? So we are good to go on that. So that's date. Let's make this an optional column, right? You see, step by step. This is the salary. We all know that this is financial data. So salary, we can go for money. Some people will go for decimal. Some people will go for float, right? If you go for decimal, always remember, most people avoid this because you have to define some 2 parameters, right? Some people prefer to go for float, right? The salary is financial data. There's a money as data type. Everyone's salary needs to be documented. Yeah, we can just say yes, everyone's salary needs to be documented. Let's make this a not null column. You must know your salary. But then if you go now to the next one, something like commission, you discover that not everyone in the company has a commission. Some people have commissions, others don't have. So you have to be careful on the commission. You cannot make commission a mandatory column because not everyone has commission. So that's a commission column. All right, this is still financial data. I'll go for money. But then this realization that not everyone in the company is entitled to a commission. You see that? So there's a difference between 0 and null, missing information. This is not missing. This person's commission is 0. They did not work hard enough to get it. So it's 0. It's different from Blake, Clark, and see, these ones, their commission has not yet been set up. So I want you to see, so null is not a number. 0 is actually a number. It means you have 0 commission, right? It's different from blank, right? So we're going to see some questions and we're going to address that. Is that the last column? I don't think so. Let's go to the next one. See, gradually, when you understand what you're doing, the department number, this is where things become interesting. We have to tell the system that, hey, this column is a foreign column. This column is being pulled from the department table. And so to be on the safe side, anytime you specify a value for the department number on this employee table, you must make sure that value or that department exists on the department table. And so this is how we're going to code that. First thing, you have to understand that in making something a foreign concept, it must have the same data type as the primary. This column department number is a borrowed column. So we have to make sure we are capturing the same data type. For you to do a foreign key primary connection, the foreign and the primary must agree on the data type. This is very, very important. See? And you must have defined this as a primary key before you can reference or tie it to the foreign side. Right. So I can stop right here, but this is not what I want us to do. I want us to enforce that concept of referential integrity. The idea that for an employee to be assigned into a department, that department must exist in the company. You cannot hire an employee and assign them to a ghost department. You see what I'm doing right here? I'm mapping each employee's department to the existing department in the company. This is company approved. See, you're not gonna see a department right here which does not exist. This is our source of truth. The department table is the source of truth. See, so referential integrity simply means you take up a value like this and you look it up and you see it. This is the accounting department. You take up another value like this and you look it up, confirm that's a research department. See, and it is true for every single one of these values. If a value occurs right here, which is not on this, that is a foreign key violation, and the system will not allow you to insert that employee because you're assigning them to a department that does not exist. That's a foreign key violation. How do you make a column a foreign key? Easy. You just put the keyword foreign key, just like what you did for a primary key. See, but the primary key stays on the same table. A foreign key creates a connection. Whenever you hear the word foreign key, it's a relationship. Right, and I will show you the database diagram for this table. You will see that the department and the employees tables will be connected through what? This foreign key, because this is the extension references. This is how the referential integrity will be enforced. So references, I'm missing a keyword right here. See that this is the extension you do for a foreign key. Please take note, a primary key stays on the table of origin. Right, but then when you take that primary key and you put it on a foreign table, you have to indicate the foreign table to which will be tied to this. Foreign keys are not defined like this. See, this is very important. You have to reference the parent table. And what is the parent table? The parent table is this. Right, so this is how the employee table will be connected to the department table. And some people go ahead and put the primary key column, but this is not necessary. Once you reference it, the system understands is this. So it always ties the foreign to the primary, and that's why this table must have a foreign key, a primary key defined on it. If this table doesn't have a primary key, you cannot reference it in a foreign key reference. This is very important. The system will automatically go now to this table and tie department number to department number. And that's at one-on-one matching. So any employee you introduce into the employee table on the department side is very special. Any value you put on the department must exist on this. That is that foreign key connection. So foreign key is all about relationship. It is what connects two or more tables together. And that's the concept we explore when joining tables. This is really beautiful. A lot of things are being revealed in this session, and it's making sense because we've gone through the journey, the SQL journey. Right. So now we can tie things together and connect things together, and it reveals a lot. And that's the concept. If you want to join the department table to the employee table, you're going to use the department number, what we call the mutual column. That's basically the primary foreign key connection. See, this is and that's how you code it. Simple thing. That's the coding right here. You put the keyword foreign key and then you reference the connecting table and make sure that connecting table has a primary key with the same data type as the column on which you're referencing. This is very important. See, please, if you miss out any comma, you have a syntax violation. This will not execute. Right, so this is very important. I want you to see the structure, and that's why this code is very important. The one we saw on the internet, this one right here, so that you understand the structure. Every column have a name, data type, and then followed by constraint. You put a comma and go to the next. See, this is pretty much what we've been doing. You see, once you have this structure in mind, you can just scan through line by line, and if you see any anomaly, you'll be able to recognize it. If your brain is tuned towards the correct thing, if you see an anomaly, incorrect stuff, you'll be able to identify it. That's how you just run through a code and spot the errors. It's something that comes with practice, a lot of practice. I bet you're going to be making a couple of errors on this. It will give you headache how to trace the error, But then just remember that you want to see a column name. You see, I'm not trying to confuse you by putting several things on the same line like this. This is still valid, but that's confusion, right? I want you to keep things easy. Readability is very crucial when you're coding. I can fuse all of this in one line. It will still execute. It's not a syntax violation. But then, you see, it is very important that you outline them one column on a single line so you can go through. And if I had a comma right here missing, had another one right here missing, I see I can easily go through. This is fine. Go to this one. This is fine. Go to this one. Oh, this is missing a comma. Include that. Go to this one. This is fine. And when you have this, just simply expand on the plus. And I see, oh, this is missing a comma. Right? But technically, you can miss out something like this. Right? It could be headache for you to understand what's going on. I see a column without a data type. Every column must have a name. True. What's the data type? I think this is a constraint. So that's how you spot when you understand that structure. Right? Please take note. This structure is very important. What is that structure? Right here. I didn't put much. This is the general structure. This is like the blueprint. This is very important. Foundational knowledge, right? And you can see some people even go ahead and indent, just put shift out, draw a line, but this is just extra stuff. You don't really need that. See, this is just ways to make your stuff beautiful, formatted, enhance the readability. You don't really need this, right? See, but this is really, really interesting when you outline them. Make sure people enjoy reading your code. Readability is key. See, and we understand why you cannot just put foreign key like we did for primary key and end right there. No, the goal of a foreign key is to create a relationship, connects one table to another. So that keyword references needs to be added. This is the only thing you extend, and then you put the connecting table. So this table and this table I'm creating will be in a relationship. They will be connected. And I'm going to show you the connection from database diagram perspective. If we're good with this, bundle this and execute it. If you have an error, we can troubleshoot the error together. Just bundle that. Make sure you pause, go line by line and try to spot those anomalies. Do I have an opening parenthesis? Yes. Do I have a follow-up closing parenthesis? Yes. If you have this missing error, see that? All right, so don't hurry to execute. Take your time and go over line by line. I'm creating a table called this, and it's going to reside in this schema. I have an opening parenthesis. That's the environment for my columns. It's right there, an opening one and a closing one. My first column is this. It's an integer primary key. I have a comma, takes me to the next column. Same thing, comma, just like that. Validate all of that. And once you're comfortable, please remember we've executed the ones above. So you're executing just the new one you build, and you're highlighting everything. Some students select this part and execute. You see, you're missing the closing parenthesis. You get an error. The entire script needs to be executed for that create table for the employee. See, execute. Once you have a successful message, you feel happy and just dismiss it. And I have to go back and refresh the North Star database. Refresh. Go to the table. I should have a second table added. See, I have the employee table. I have the department table. We've explored the employee table. Let's explore the department table. By exploration, I want you to expand and go to the columns folder. Now, I think we've explored department. What we create is the employee. Let's expand the employee, go to columns. And let's make sure that the column definitions we have right here is aligned with what, of course, this is what builds this. So what you see right here will be captured right here. You have to understand this is the code that was used to build this. So whatever we stated right here is being captured right here. All right, but I want to give you more flexibility on the understanding aspect of it. This first column is the employee number right there. Why do we have a key symbol? Because we made that the primary key, PK, primary key, an integer, and of course every primary key column is a not null column. That one is non-negotiable. Once you put primary key on a column, it's a not null column. Remember that. And also it's a unique column. Those two go together once you put primary key. The employee name, VACA 100, that's exactly what we stated. If you went for VACA 50, you see VACA 50 and VACA 50 right here. Not null, that's what we stated, mandatory column. Job and VACA 100, if you put 50, you will see 50 right here. Not null, not null. The manager, see, we discovered that not all employees are assigned to managers. So we could not make manager a mandatory column. So that's a null. See, that's the level of detail I want us to be able to understand. Higher date, that was a date. By even when I had to test some of the values, yes, we coded as a date. There was no time attached to the date. So if there was a time, we'll put date time. See, we made that a null column, right? Optional column. Money, salary, same thing. Commission, not everyone has a commission, so we do not. See, now this is the interesting part. This is a new stuff right here. Why is this a key, and why is this key different from this one? Right. So the system has a dark black key for the primary key, and then this white key right here, foreign key, FK. And remember, when you think about foreign key, you think about relationship. That's what connects one table to the other. And that's why this part is important. References. You cannot put a reference when defining a primary key. A primary key does not connect to other tables. You see? No, it doesn't do that. You see? The foreign key does that. So when you think about foreign key, what keyword that comes in mind is relationship. So a foreign key connects two tables together. So that's why the references keyword was indicated or specified together with the connecting table. So we are building the employee table, and through this column, it will be connected to this table. And that's what you see right there. Further information about keys can also be found in the keys folder. Right. For example, this is the name of the primary key column. The system builds that there are two keys on this table. We have a primary key, that's a name right there. We have a foreign key, that's the name right there. So you see that on the keys folder. They also have a constraints folder. If you build other constraints, you see them. That I will come back to that later on. Right. So this is giving you more depth. Right. Again, if you want to do a select star from the table you just created, you're going to see the reality of a create statement. We put in place the structure of the table. We don't yet have data in this table. To put data into a table, you need to run an insert statement against the table that you've created. Right. So create comes first. It builds the process. Insert brings in the furniture. It's like you build a house. That's a create statement. To insert data or to put furniture into the house, you have to use the insert statement. So the house has been built. We just need to move in furniture. See. All right. So at this point, we have an empty table. Empty in the sense that there are no data, no rows. Every table must have columns and rows. The creation part takes care of the structural part of the table, the columns and the constraints. That's basically what we've specified right here. The insert statement will now bring in rows into the table so that the table is now fully defined, columns plus rows. You have to understand this. Right. Questions. So when you add this, remember to save. As you're typing, we are building the script. And now you begin to see, I've been sending out scripts like that. I just tell you, open and execute. Some of you maybe got bored, say that we are executing things, we don't even know how to build them. Now we are building those scripts. All right, so make sure as you're building, you're saving. Save the script. And I always like to comment out the select style from, but this is just a testing So in the final script, this will not run. Only the parts that are exposed will be allowed to run. You see. Now I want to take questions. So you should have the two tables created. The department one is right here, right? And then we have this, the employee one. Of course, we can all agree that these two tables are not complete. We have the column structure in place. The data or the rows aspect of the table is missing, right? And that will take us to what we call the insert statement, right? But before we get into the insert statement, I want to pause right here for questions. Please, I hope we are achieving this. If you have any errors in your code, you have to draw my attention to your screen, right? This table has a lot of columns, so I'm going to pause. I want to make sure everyone types out this and execute before we go to the next. So please just let me know once you're done, or anyone still working on this. I want to pause right here and give you time to complete this. These are things I want you to type it out yourself. You're building your own script. All right. And let's make sure we stick to the requirement. Just create what was provided. Same names. See, if we want to get to the data portion, we're going to get the same. All right. Okay. Anyone still typing this? Okay. So we're going to go back to the first table. So you see the first part, we created all the tables. This is very important. We have the tables all set up. And now we're going into the part where we're going to be adding data into the tables. And this is very important. Start adding data on the table with no foreign key. We cannot add data to this table first. Why? Because it has a referential lookup. Right. If you're adding data into the employee table, you're going to be adding, you see, this is the problematic column. You see, for this column to accept values, these values must already exist in this. See, that business knowledge or idea of avoiding to hire employees and place them in ghost companies or department. You see, so you must first of all build or insert same thing. building process, we started building this table. In the insert process, we have to start inserting data in this table. This is very, very important. Right? If you look at this right here, we did a reference. You cannot, first of all, build the employee table. How will you create foreign key and reference the department table of which it has not yet been created? So you have to set up this first. The department table exists. Now you see we can reference it. So the parent table exists. We can now reference it. See this reference. If I put, for example, department 1, the system will give you an error because you see you cannot reference a table that does not exist. See, the foreign key is referencing an invalid table. Right, this is very important. These are steps you have to remember when building databases. You build those tables that are having no foreign key. Set them up first. When it comes to inserting data into tables, you also do the same. You start by inserting data into the tables with no foreign key constraint. So we have to establish this first so that this comes with the foreign key constraint and start doing the lookup. If it looks up 20, 20 already exists because we've added this to that table. You see, this is very important, right? So this takes us to the insert statement. I can take you to Google. Right, we Googled this for the create statement. And let me just back up. I can just go to this side and just change this. How to insert data into a table in SQL. How to insert, see, or how to add data. How to insert data into a table in SQL. See that? And if I see that W3 schools again, this is the my SQL. Right. This one works for my SQL. I want to check out. This is my SQL. Sorry. So this I'm going to go for this version. The language we're studying is not MySQL. It's kind of similar, but some keywords might be off. So this is the correct. This is the correct one. W3 schools, that same website, but this is the valid one. See. So the insert into statement is used to insert new records into a table. This word is very important. New records. It means the records did not exist before. Our two tables are blank. They're empty. This is we begin with the department table is empty. So what we bring into new records. So that's the key stuff we're going to use. I'm just going to copy this name. I will need that. All right. So I want you to see that this is going to go through an insert statement. All right. This is how you set it up. Insert into. You provide the name of the table. And then this one right here is a list of columns that will be receiving values. If all columns will be receiving values, you don't need this. See? And it's typical, see right here. If you are adding values for all columns of the table, you don't need to specify the column names. You see these column names in parentheses. Since you're providing values to all the columns, you don't need that part. You just dismiss that and you put the values. And now each value comes in row by row. This is the first row. I want to show you this row by row concept so you understand. Data is inserted into a table row by row. So based on what we've just seen in that syntax, it's going to go through what? Insert. That's the insert into. We provide the name of the table. We are beginning with the department table. This is very important. Begin with this table. It has no foreign key constraint. This has a foreign key constraint. You cannot start inserting data into the table with the foreign key constraint. No. You have to do this first so that when we get to this will be looked up. It already exists. This will be looked up. You've already created that. You see, this is very important. Right. So that's the syntax insert into. That's the name of the table. Since we're going to be providing data into all the columns, right? We don't need this part where you list out all the columns. And this you have to come and separate them. We don't need this. I'm just going to show you this. Right. You can put it, that's fine, or you can kick it out and just go to the values I'm just going to put values. So the keyword values, don't forget about that. It now initiates. This is opening statement to insert data into a table. The values now ushers in the values, and every row has to go in a set of parentheses. Please take note, data is inserted row by row. What do I mean? This is the first row of data. This is the second row of data. Third row, fourth row. See, this is very important. So data is inserted row by row. What we can do is that we can copy this first row, right? Control C, and you have to place that row inside the parentheses. Control V. This is not enough. You get an error because you've not separated out the values into the different columns. You see how in the table, this is separated out. You see 10 goes into this. See, this goes into this. See the border on the cells. So we have to do the same. And in SQL, we use the comma, right? So 10, if I just push display that employee stuff, let me show you the content of this table. Let me run this so that you understand. Right. So the columns, the values will go into the columns in the order in which they were defined. So if I put 10 right here, it means 10 is going into the department number, which is exactly what you see right here. Accounting is a department name. So accounting goes into this. And then this New York, that's a location. It goes into this. Now, then, let me just go ahead and put the commas. But this is not enough. Can somebody tell me why we have these errors persisting? You can understand this because we've done the select statement and we know that this is a string. Strings need to go into a string environment. New York is a string. String needs to go in a string environment. And that's how this becomes nicely done. You see that? This is very important. Please, these are key things to remember. Data is inserted row by row. Each row is placed in a set of parentheses, open and close. You insert the values right there, and you make sure you comma separate them. Right. So let me repeat this process again. I just initiated an environment for that first row, went into the document, copy the first row. Right. I don't think we are teaching you how to type right here. I will not be the best person to do that. Right. So I'm just copying and pasting things. But of course, in companies, you don't type stuff as well. Right. So this is it. Don't be tempted to go and spread this. Right. Then this is a serious error because you have 3 columns, but you're providing 4 values. How will it go into 3 columns? So New York, it's like this. There are 3 values, 1, 2, 3. We've introduced the commas, but why are we still getting error? This is an integer. Integers don't go into a string environment. Accounting was stored. It's going to the department name column. This was stored as a string. So this is NVACA. It has to go like this. Very important. I'm now showing you errors, possible sources of errors when you're inserting data into a table. This is a string. That's a location. It has to go like this. See that? This is very, very important. I want to show you how one row gets inserted, and I'm going to show you how the second, third, we're just going to combine the next set. So this is going to be our first insert statement. Please take note, you are just highlighting the new part you've typed in. Every other part above has been executed. So don't just run execute without highlighting what you want to execute. This is the part I want to execute. See that? And you have to pause and understand what this is doing. We are inserting data. Right, let me show you the thing. Inserting data into the department table. Right, and this process is also called populating. To populate the table means to insert data. So inserting data, technically we can call this populating. Populating the department table. So people use this terminology. Populating a table means adding data into a table. Inserting data or populating department table. Just dismiss this and put it above. Right. So how to populate the table? You have to remember this technical word. It is the same as adding data into into a table. So we use the insert statement. This is the job of the insert statement. How do you create objects in SQL? We use the create statement. How do you insert data into a table? We use the insert statement. So populating a table means you're adding data into a table. I've shown you the table is blank. This is it. Right. If I run this, let me explain this all over again. So insert into, you specify the name of the table, you put the keyword values. This just tells you is one row of data will be added. Why? Because it's just one parenthesis. Every row gets into a parenthesis. So in our project, this is the first row of data. We are adding information for the department, for the accounting department. The department number is 10, the name is accounting, the location is New York. That's the first row of data we are adding. So if I go ahead and execute this, and then I ask you to do a select star from that table so that you can see where we are. After running that, please make sure you highlight. We're not running the entire script. All right, select star from this. All right, when you execute this, you see one row of data has been added. How many more rows do we need to add? 1, 2, 3. We need to bring in research, sales, and operations. All right, that will be the next insert. We're just going to bundle those three and run it. But I just wanted to see how one row of data gets inserted. That's it. I want to pause right here. Right. Please, your goal is to understand each line of code you see right here. Right. Data gets inserted into a table row by row. Each row is placed in a set of parentheses like that, and you put the values, right? And make sure you respect the data type. If it's a string, you put the string environment. Numbers or integers, just like that. No string needed. You see, this is very important. Don't forget to save your work as you're proceeding. Make sure you click on the save button, and you see nicely we are building a script. This is what I used to send out scripts, and just tell you open and execute. But now you've seen how that process was built in the backend. You see, you can comment that out. How it's now time to bring in the next 3 sets of departments. We're going to add them all together, one after the other. And initiate the first environment. This is to initiate to add the first row, and that row is going to be the research department. I copy all the data, Control C, and I put it in that environment. I initiate the commas to make sure that I see the 3 values going into the 3 columns. So I have 3 values which will go into 3 columns. See that? And this is a serious syntax violation. Again, this is a string. This was stored as nvarchar. I need to put this in a string environment. This was also stored as nvarchar. It goes into a string environment. I'm not going to execute this. I want to put a comma and go to the next row. So this is a single insert, adding just one row. I want to show you how to do a multiple insert, adding multiple rows. So I'm going to take now the sales department information and put it right there. See, and then do my commas to separate the columns. This is not enough. Do the string setup, right? And then put the comma. You see, this is good. Put a comma and go to the last row initiate the row environment. If you do this step by step, you know exactly what you're doing. You avoid errors, you pause and confirm before you execute. Right? See, I go to the next one. I repeat the same thing. This 40 is going to go into department number. That column has been dealt with. This operations is the name of a department and it's a string, right? Comma. Boston is going to go into the location column and it's also a string. See, I have to stop right here. If I put a comma, it means I want to add another row of data. The system did not provide that. See, that's the last department so far. So I have to go back and dismiss this comma and also dismiss that environment. Stop right there. So in the first example, we inserted a single row of data. In the second insert, we are doing multiple inserts. So multiple rows, as a total of 1 to 3 rows will be added. We're adding 3 new departments into the department table. You have to understand this framework. Right. I want to stop right here. Before you execute, go ahead and evaluate row by row. Don't just look at the general picture. No, look at row by row. This is good. Insert into, yes, we met the requirement for that line. The values keyword needs to be there. Very important. If you remove this or forget about this, you get an error. That values keyword needs to follow right there. And then this is history. This is inserted row by row. We have a total of 3 columns you're targeting. This first one is the department number. It goes to the department number column so that you have the scenario, this into department number. The next one is research, is a value which is going into the department name column, which is this one, right? And then next we have Dallas. That's a value going into the location column. You must be able to isolate those 3 different values going into those 3 columns. That's the build up right there. Execute. If you forget a comma, you get an error. See? So after every row, you put a comma, will take you to the next row. And now if we run this, it tells you 3 rows affected. That's just the meaning of saying 3 rows have been added. These are the 3 rows right here. We've added research, sales, and operations department. If we now do our select star from that table, this table is now up to date. It now reflects what was expected. This is it. We have a department table with 4 departments. 1, 2, 3, 4. Right. 4 departments. Right. 4 rows spread across 3 columns. 1, 2, 3. This table is complete. You have to understand that it was done in 2 phases. The first phase was a create statement where we build the table and define the columns and the constraints. Right. That's through the create statement. And in the second part, we did an insert, which brings in actual data or rows into the table. And I did this in 2 phases. I want to show you a single insert, how 1 row gets inserted. So you see a simple scenario, and then how multiple rows get inserted. See, and then finally, we now project the table. This is what we have. This table is exactly as stipulated in the project. Right. I want to pause right here. Please, we're going to finish this and then we take a break. I know phase 2, right? So that we just make sure we get this done for the first part. Right. Any questions? I haven't had any question. I don't know if that's a good sign or it's right. Hopefully that's a good sign. Right. But I need those questions. Right. I want to make sure that we I think now it's going to be easy because we've gone through the SQL journey and now we just, getting some very interesting details and, making things much more, seeing things at a much important and detailed level. Right. In the last insert statement, we will just target all the rows and insert them. Right, this is going to take a while. Yeah, but it's just formatting. We're going to arrange that. So inserting data, I'm going to use some space for inserting data into the. So this is supposed to be department, yes, and then this is employee. So we're moving now to the employee table. Right, again, remember, insert into. You specify the name of the table. We had that in dbo.employee emp. Always remember the keyword values, and since all the columns of that table will be accepting values, we don't need to stress ourselves and list out the columns. Every single column will be accepting values. Right. If you want, I can just put out a printout of the table we're dealing with, and just go towards the bottom, just put the select star from. Right, it helps. Right, so you see a printout of the table we're dealing with. This is the printout right here. Right, and then we can now, let me comment this out so it doesn't confuse us, but we have the printout of the table. Right, now the rest is history. Go to this area, copy the data, only the data portion. We have the column portion already built. You don't need to copy together with the columns. You don't need to do this. See, that's why I printed out this. So you see that the columns already exist. All we need is just the data portion, this part. So target this part, highlight all the way to this. You see, be careful, make sure every data part is included, only the data portion, all the way to this. Control C, that's the copy. Take it to Management Studio, put it right here. Control V, that's the paste. And the rest, we just have to make sure we follow those guidelines, like what we did right here. Every row comes in with a set of parentheses, 1, 2. See, and then now we go in and split the columns. This, you see, I have a guideline of the column structure, so I know this is what, that is employee number. After employee number, I put a comma. What is this? This is the employee name. I put a comma, and that's a string, so I have to put in that string environment. This right here is the job. You see, the job of this person Smith is a clerk, so I put that in a string environment, followed by comma. After the comma, it takes me to the next column. The manager, this is the manager ID. Right, that's an integer. I put a comma. This is what, a date. Dates are strings. Remember that. Put this in a string environment. Put a comma. What is this? This is the salary. That's a number. No string is needed for that. This is also, so this person has no commission. You have to be careful. You see, they say no, right? This person has no commission. I almost got this wrong. This person has no commission. The 20 you see right there is a department number. So how do you put no commission in SQL? That's null. Please, null is not a string. You don't do this for null. I want you to understand this. So it's just null. That person has no commission. Put a comma, and then this goes into this. See, it is important. If I never had this outline, I would have confused that. Right, and you end up doing something like this. See, this is a serious error because the number of columns you've stated that you want to insert data into is fewer than the number of values. How many values do I have? 1, 2, 3, 4, 5, 6, 7. How many columns do I have? 1, 2, 3, 4, 5, 6, 7, 8. If I execute this, I'll get an error because the number of columns are fewer than the number of rows, the number of values I want to insert. This will give you an error. Execute, error. Column number or number of supplied values does not match the table definition. right? So this, I want to show you areas where you can have an error and how to fix them. So if you go back to the source of truth, which is this, the commission is missing. So commission, how do you missing information in SQL? That's null. See, I'm not going to execute this because I know it's going to go through. So I want to make sure that I go to the next and format, right? Please consult this as your, if you go to the next one, it has all the data. So first of all, check that and before you format, right? And last time I showed you something very interesting. If you want to type across multiple lines, can you all be on my screen? Right, it must make sure it's a straight line. Right, this will save you a lot of time. And the only two things I see straight line is this one and this one. So instead of going to this line and put this the same symbol, I can just draw a straight line. Could shift out, hold down the shift key and the out button and press the down key. You see, all the way to this and stop on the last line. And now you can type that symbol. It just shows up right there. See, only when you have a straight line. I see a straight line right here. And what do I need in this space? I need a comma. You see this comma right here? It has to show up for every single one of these. Yeah, you can go ahead and decide to type them one. See, if they're 10, you have to do that 10 times. But I can just draw my line, shift plus the out button, down arrow. I draw the line, only works for vertical straight, you see, and I put a comma right there. See, same thing on this. This has to show up for every single one of these. And I see a straight vertical line that I can draw. Don't attempt this if there's no straight vertical line. There must be a line. You see, in this one, I have to put a comma right here. It's not aligned straight. I need to go in there and do it manually. So in this one, I can just put a straight line, shift plus the alt key, and then you press the down arrow button. It takes you, because we're going down, stop right there, and you put that string environment. The other ones, nothing is aligned, so you have to copy this. See, I'm just showing you easy ways to do this. Control C, and then you paste them across. One, two. See, you must have studied the structure of the employee name. It's just one name. So this right here is just the name of the employee. So I copy that and just paste. I need a closing of the string and a comma. Closing of the string, comma, on all the lines. See, and by doing this before, you know you're done with this. So we're gonna conclude this and take a break. So before we go on the break, we make sure everyone is on track with this. So what do I need on this? I need the close. I have the comma already. I just need this closing for this segment. You see, I copied that. Or you can just, instead of doing control paste, it's going to take you long. Just put your cursor this, go to the next place. This is faster than control V. If it's one symbol to type, it's faster. You see. If you want to do it row by row, fine. And what do I need on this? These are two, so I'll prefer to do control C, control V, and just paste. So right here, that symbol is needed. You're closing the parenthesis, which is open right here, and you're putting this on a separate column. So control V right there. Target all the spots right here. You have to be careful on this. Right. I think it's better to do this row by row. Right. The danger is the commission column. Not every employee has a commission, so you have to watch out. The mistake, this is not right. See, this has to go away, this has to go away, this has to go away. So it is on the name of the job title. Click on this. That's where you close that column and you put a comma. Now these are what? These are the manager IDs. So we just need a comma after each. Comma, 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 right here, you see. Now this is that person with no manager ID. Watch out, there is that guy with no manager ID. See, so you have to put a null before the date, null right here, and then you put comma, and that's the date. This is that person with no manager ID. See that? So you have to be careful when you do. I think it's best to do it row by row instead of just doing it across. So for the next ones, I'll do it row by row. Right. So I look up the information. I'm on the second row. This person has a valid date and a salary and a commission all the way to department number. So that's good. I will just target this. This date is a string. I need this and this environment, and I put a comma. And this is the salary, commission, and then I close right here. Please take note, this row has to have a comma to separate it from this row. And the end of this row, you have to have a comma to separate it from this one as well. Right. So I'm back to this step employee, this person right here. What? They have a salary commission. The confusion is going to be on commission. Right. So make sure you check they have it. It's good. And just go now and comma separate, or you put the string environment. Right. Please do it row by row. It's going to be easy. So you can check. Now this part, you have to close this and you put a comma. You see that the first three are clean. They look nice. You have to do that for all the others. Now Jones, let's check the information for Jones. Jones has no commission. You have to watch out for Jones. So on this date, that's it, put a comma. Commission comes afterwards salary. This is Jones' salary. I put a comma. Before I go to their department number, which is 20 for Jones, see, there's a missing commission. So I have to put a null. Null is the symbol for missing information. Right, you cannot leave that space blank. Right, this is very important. You see, as you're doing it, it's cleaning up. The first four are good to go. You have to do that all the way. I go to Martin. Martin is good, has every information, so that's good. Just make sure the dates are in that string environment, comma separate them. You move to this is salary, this is the commission, that's the department number. Stop right there, close that, and then you put a comma. See, this will take some effort, but I really want you to work this out. Right? The other ones will just copy and paste, but this is something you have to work it out. Blake seems to be missing. This is salary, they are missing commission. You see, and that's it right here. Blake is missing. They have a salary of this, no commission. Right. So immediately after salary, before we get to department, we have to put a comma and initiate a null. Very important. Right. Please take your time and build this. Don't rush. Make sure you have this correct. The system will guide you to show you the ones you've built correctly, and then the ones with an error, you have that red underline. This next person, that's Clark. Clark is also missing commission, so you have to watch out. Immediately after salary, you have to put a null to indicate missing commission. This is salary, put comma, initiate a null environment right there, put a comma. As a department number, close that row, put a comma. You see, as you're building it, always go back and check. Scott is an analyst. Scott also has a missing commission. So immediately after salary, I'll need to put a null for Scott. This shows understanding of the table, right? And once you're done, everything looks clean. No error indicators, no red lines will be on your script. That's when you know you've achieved. Okay, president, yes, we've talked about this. This is a null on manager, no commission also, right? So there's already a null on manager. This is a date. You have to make sure we embrace this in that environment. Put a comma. This is a salary. Immediately after salary, you put a null. The manager has no commission, missing commission. The row ends right there. Put a comma and go to the next. See, when you do this over and over and over, you get a good understanding of it. So now it's has a commission of 0. That person's everything is provided. There's no null that needs to be included. comma, commission of 0. Right, stop right there with the comma. You see, I'm almost heading towards the end, and every other of this 1, 2, 3, 4, they have no commission, right? So very important to look up that information so you know how you're going to approach that. So after the salary, no commission, there should be a null right here, comma, then this, comma, right? Same thing, the date, we have to put that string environment, comma, the salary is this, no commission, null, the department number is right there, put a comma, go to the next, oops, right here. String right here. The last row takes no comma. If you put a comma, it means you're initiating the possibility for a next row. So it stops right here. The last row has no comma. And you notice that everything has cleared out. See, I want us to stop right here. Make sure if you have any error, please see the line on which that error is indicating, and come to my screen and check where the error you might have missed out. See, you can miss out a single comma, you get an error. The comma is there, but then you forgot to close a string, you get an error. There's a lot of possible errors. See, sometimes only one error is just going to mess up your entire script. So please take your time and do this gradually. It helps you to understand the flow, the syntax. Right? We are inserting data into columns. Every value has to be comma separated. That's the first thing you see. Right? After each value, there must be a separation, comma, to indicate the next column. The strings have to have an open string environment and a closed string environment. Every row is inserted in a set of parentheses, open and close. Every row. And you have a comma right there. You move to the next. These are key things to focus on. You see. Before we go on break, I want to make sure that everyone has executed this. So we're going to wait until everyone is good to go. Then we take a break, because when we come back from the break, we get into phase 2, where we start solving these questions. All right, so I want to make sure that if you have errors, I can share your screen, we take a look at it, troubleshoot, and we'll fix it before we go on break. This is very important. So I've not yet executed. I want to make sure that I have no error indication. Don't hurry to execute when you have errors on your script. All right, make sure there's no red underline. Right, and take a while to just look over. That's a pause and confirm methodology. You do something, you pause, confirm it before now you can execute it. Right. If I execute this, I'm now inserting data into the employee table. It says 14 rows of data were inserted. Let me go back to this. Are we expecting 14 rows of data? The count out of this, it should be 14 rows. So everyone should have that 14 rows of data. And now if I do my select star from that table, I see the 14 rows of data right here. So we have from Smith all the way to Miller. All the way to Miller. Right. Please just notify me on the chat message, or just turn on your microphone and let me know if you're successful on this. We have to wait until everyone gets this done before we go on break. If you have an error, just notify me. I'm going to share your screen. You just troubleshoot and fix the error so you can proceed with the execution. Right. But please take your time and inspect this before you execute. Don't rush. Okay, guys, I think we're gonna go ahead and take a 30 minutes break. I want to give enough time so you can troubleshoot, you can work out this. And if you have any errors and they continue to persist, the first thing after the break, we're gonna work on it together. So I'm gonna set the alarm for a 30 minutes break. Oh, Lanita, you have a question?
Yes, sir. I wish you should leave. I don't know how you can do it to leave
Oh yeah, the screen. Oh
your
yeah,
own
that's
example on the screen
right.
so we
Yeah.
can be doing ours.
Okay. Anyway, once the 30 minutes done, it's going to alarm. So I'm just going to leave my screen like this. So if you have any issues, you
Okay.
can just follow the line. It's going to be line by line. Make sure you have this line correct. So just evaluate the line by line. That's the best advice I can give. All right. I'm going to leave the screen like
Okay.
this. Okay. Okay. See you after the break. Hey, hello, are we back? Okay, so let's address the errors, if any, encountered. Are we all good with the insert statement into the employee table? Okay, make sure you save the script. So this is what we have built. Just make sure you save the script. So I have this as the North Star employee database, North Star database script. I should have that in this SQL project. So this is the script right here. So if I shut down this, I'm not going to panic because I have it saved. So if I shut down this script, I can go back and open it. So I can just click on this and navigate to the class folder. This is SQL project. This is it right here, North Star database script. All right. Okay, so once we're done with the script, I want us to shut this down. We're gonna open a new script, which will be the phase 2 part of the North Star project. So this is the first part right here. Assignment on operators. So this is divided into different segments. We have operator examples. We have assignments on grouping. We have the assignment on subqueries. We also have assignment on joins, assignment on outer joins, assignment on self joins. Right. So I think now we should be ready for the first. I'm just going to copy this title right here. Right. So this is, first of all, the script is the solution to the North Star project. So this is I'm going to put a new title right here. And the first part we're going to be looking at is assignment operators, right? And so for each of these questions, you're just going to copy them. Copy this one, for example, and then bring it to the management studio. You should paste this as a block comment, right? And next, you can just proceed to start solving this question, right? So the first thing we're going to do is connect to the database itself. I'm just going to write the script again to connect to the North Star database. And make sure you save the script as the solution, North Star project solution. Right. So I'm going to change this to North Star project solution. So we're going to begin solving this. I'll make sure that this is in SQL projects folder. Save that. Save it in a folder you can recall. Right. So this one says display all employees who are getting this and excess salaries in department this. So remember, in the North Star we have two tables. We have the employee and the department table. So if you have a picture of this tool, let's do this, and then next as a department, and then next let's do the employee. This moment, let me check. Yes, this should be recognized. Yeah. We have this, and you see how the nulls show up. The null we had in the script. See how they show up in the table. I think you're familiar with that. And we have this. All right. So if you read this question, it is talking about the employee, right? And if you project the employee table, we're looking at employees getting this and excess in salaries. We have a salary column right here. All right. I need somebody to help us and build a condition for this. So my understanding is that this is going to be a single table query. We don't need a department. We're not asked to do anything on department. We have just to point to this in the where clause, and the information is available right here. So this question can be solved just staying on the employee table. All right, we don't need that. So that's the base table we're going to be using for this question. And we are not getting all the rows. You have to understand that there's a condition right here. We're getting those that have a salary of this or above. Say this and excess. Right. So there's going to be a where clause right here where the salary. I really want you guys to solve this. This is a revision, so I should be able to, pause and give you time to work on this. This salary greater than or equal to, and that first quantity, that's the first condition we've enforced. And there's another condition on the department. It should be 20. So you have this condition met, and the next condition should be on the department. And so the department number, it's captured like this: department number equal 20. Right. If you keep having this indicating, you can just go to the edit and you go to IntelliSense and you refresh. Usually when you create a new database, it takes a while for IntelliSense to recognize the column names. Right, so it's easy. Just go to the edit menu. There's an IntelliSense. Go to the right hand side and do refresh the local cache. Right here. Right, this is valid, so it now recognizes those additional columns and table names as well. Right. So this is a display of all employees who are getting this or more in salary, and they're in this department. I want you to recognize the two conditions involved in this question, and this is what we're getting. So it asks about employees. We can just limit this to the employee number and the name. And M name, this is good to go. Right, these two information are good to go. Right, these are right. Or if you want to return all the columns as defined, display all employees. Right. Just make sure when you solve, click on the save button to preserve your work.
Hello, sir.
Yeah, Anita. Yeah, question.
Yeah, yes, I'm trying to execute the table, but
Oh, you have
it
an
is
error.
not. Yes, I'm having an error.
Okay, just a moment. Let me share your screen.
Hey.
Oh, did you get the request to share your screen? Okay, awesome. So it says incorrect syntax near 73606. That's 69. Yeah, 7369. So you go to 7369. What do we have right there? So yeah, everything looks fine. Can you do control arrow on your keyboard? I want you to get rid of the output window. So when you do control arrow, it's going to delete the remove the output window so I can see the full extent of your query. Just hold the control button on your keyboard and then you press the arrow, letter arrow. Oh, that's for Lanita. Can you hold down the control key on your keyboard and then you press down the letter arrow? Okay, excellent. Yeah. So everything looks fine on your code. Let's see. Okay, can you go to the top? Can you scroll all the way to the top? Okay, highlight the insert statement into the employee table and execute. Let's see what you have. No, you have to highlight everything, not just that one. Everything all the way down is right there, all the way down, and click on execute. This is the full insert statement. Yeah. This statement conflicted with the foreign key constraint. Conflict occurred in databases. So the column department number, this has been terminated. So something is wrong. Can you double click on the output, the error message? You see where you have that red line, the output. So just double click on it. Yeah, double click on it. So whenever you double click on the error message, it takes you to the offending line. So the problem is a foreign key. So there's a value. Okay. Can you do a select star from department? You see that the comment you have above that is deactivated or commented out, just go above, select star from department. Yeah, the next one above, select star from department, highlight select star from department and execute. I want to see the, not the comment, just highlight without the comment. Yeah, just go inside and highlight without the comment. Yeah. Yeah, that part, yeah. Just highlight and execute. So you must make sure you have all, you see, you're missing a couple of departments. That's why you're having an error on the employee side. So your department table, you're missing 10. You should have, there are 4 departments. If you go back to that table, you should have 4 departments. There's 10 that's accounting department, there's 20 research. So you have 20, 30, and 40. You're missing 10. So remember, when you're trying to insert data from a foreign key table, you must make sure you have everything on the parent side. So let's go back to, take me above, just go above into the, yeah, this one. So look, yeah, you built it but you did not execute it. So can you go and execute that one? See that line where it has 10 account in New York? Run that insert statement. Yeah. No, not that, just that line. You have to run the entire, go above and highlight the entire insert. No, go,
Okay.
yeah, scroll down. Yes. So this, that says inserting data in the department table. That's a comment. Put the comment symbol in front of it. Two lines, two hyphens in front of, yeah, where it's giving that error inserting. That's supposed to be a comment. The line above where you have that error indicator, yeah, that one, that should be a comment. Put the comment symbol in front of it. Excellent. And then now run this part that says insert into that, yeah, so that's the one department you're missing. So execute that. Yes, that's perfect. And then if you do a select star from the department table, now you have all the 4 departments. You just go back to that code you executed previously. Yeah, that one. Do a select, execute that one. Now you're good on all the departments. Yeah, so now before we execute the employee, right? I want you to
Yeah.
do a select star from the employee and execute. This is to check. I don't want you to go to the bottom, take us all the way to the bottom of your script. Right, and then just type a select star from employee. Select star from DB. Yeah, take us a couple of lines down. Yeah. The reason is because we want to see the current data you have in that table, if any, so that we know how to proceed. Right. So select star from dbo.emp. Is that emp or what's the name of that table? dbo.emp, something like that. Yes, that's right there. emp. Yeah. Yeah. So just execute that line, that one line of code. Right, so that this will help us to know the current nature of that table. Good news, there's no data in it. You see that? So what you do now is that you're gonna run the entire insert statement for that employee table, including all those rows you've built. Right. So now you go above, go to the top on that insert right here. Now you highlight. Oops, no, go below again. So you have just one line, one segment of code to insert. This one right here. So begin with the insert into dbo.emp, and then you highlight all the way down to the end of the insert statement. Now we're going to bundle everything. No, not the select. Don't highlight the select, just only the insert statement. Yeah, that part all the way down to the rows. Fantastic. This is the part you're missing. Now run the execute. Perfect. I want you to understand what happened. So you were inserting employees and pointing them to department ID 10 or department number 10, of which the department number 10 was not in your department table. Yeah, that was the error. Yeah, but that's fine. I hope everyone will follow through this and understand.
No.
So yeah, this is fantastic. Click on the save button. Make sure you save this code. Click on the save button. Yeah, and now you should be ready. You can close this script. We don't need it anymore. You have everything built. You can just review it. But yeah.
So I'm following it. Mine is still
That's Lane. Okay, Lane, I'm going to come to your screen. So Lanita, you can close the script and go to a new script where we solve that first question. So go back to the PDF document and then you solve that first question. Yeah, so you're done with phase 1. Close the script. I'm going to go to Lane's screen. Okay, Lane, your screen is next. Okay, so Lane, we're going to do the same thing. The first thing we're going to do is test your employee table. So go run a select star on the employees table. I want to make sure you have the employee table nicely built with all the different, no, not the employee, the department, sorry, select star from department. Yes, a department. So highlight that and execute. Just that line, yes, perfect, and execute that. Perfect. So you have all the 4 departments needed. Excellent. Now do the same. Do a select star from now the department table. Yeah, do this. So I want to see where we need to start working on. Right. So you have the department table perfectly built. Let's check how far you've gone with the employee table. So just execute the employee table. Let's see. You have to highlight the last line. Yeah. Did you execute? Yes. So let's see 1, 2, 3, 4, 5, 6, 7, 8. Excellent. You have all the columns built. So the only thing you're missing now is just to run the insert statement for the department. So let's just a moment before you execute. Let's check out. I think your code is clean. Yes, no error indicators. Everything looks fine. Let me just a moment. Let's see. Yeah, everything looks fine. Yes, go ahead and execute. So column name or number of supplied value does not match. Right. So there's something, the nulls, you're missing something. And can you double click on that error message? Just double click on it. So usually when you get an error, double click on it. So it takes you to this. So the error says that the column name or number of supplied values does not match. So in one case, you're providing less values and number of columns stipulated. So it should be, let's see if you can spot that. So we should have this. So the confusion will always be around that salary, compensation, commission, and department number. So salary, combination. And then check the last row, Miller. That department number 0, that's not possible. Check the requirement. Miller is assigned to what department? That's 10. Yeah, put a 10 on that. Transform that into a 10. You see what I'm saying? Go to the last row on your insert statement. That's the entry for Miller. Yes, that row. Miller is a clerk. And then go to, if you look at the department number, that's the last value on that row. You put 0, but that should be a 10. Yes, that's department 10. There's no department 0, so that should be 10. Then that's correct. Let's see what you're missing again. So yes, Ford has, let me see, Ford's entry. Ford has a null. So from Adams all the way to Miller, they have missing department. So let's check on your case. Yes, so the last 4 is missing, not department, sorry, the missing commission 00. Yes, okay. And then Turner has 0 commission. That's correct. And then from Blake all the way to King, they have missing commission. That's correct. You have it null throughout. From Blake all the way to King is missing commission. All right. And then what's the next one? Martin has a commission. What is missing is Jones has a missing commission. That's null. That's correct. Yeah, I think it should be, everything looks fine now. Column name or number of supplied value does not match. So something is wrong. One of the rows is missing something. Has anyone seen anything strange on Lana's screen for the insert statement? I think those data values they all looks fine. Insert into department. Oh no, you're inserting into employee. Sorry. See the insert statement that should be employees, not department. See the error? Yeah, yeah. It should be inserted into your yeah. Excellent. Now it should be good. So yeah, we now have the right table. So yeah, okay. And then do a select star just from the two. I want to make sure nothing was done on the department side. Still intact, yes, excellent. Then try now the employee side. Fantastic. Everything looks fine. Yeah. Make sure you save the script. Click on the save button to save. Right. This is good. Yeah. Awesome. So you just said, I think you're in the right part is just in the table name that you needed to change. Yeah. This is good. Idris, are we okay? Did your table execute both tables? Do you have data in both of them?
Yeah, it's good, sir. It's good.
Okay. Excellent. What about Tunde? Are we good? Tunde, do you have data in both the department and the employee table?
You can share my screen.
Okay, let me share your screen. So, Lane, I want you to go to the first question and do it. Same with Idris and Lanita while I'm working on the Tunde screen. Tunde, I'm going to share your screen.
Okay.
Say which question, please. Which
That's Idris. Yeah, Idris, you have a question.
no, I'm the one. So I said we should go to what and do what which question this one.
Oh, that's the second part. So once you've created the two tables above, you look at the question, go to where it says assignment on operators. The first question says display all the employees who are getting 2,500 and excess salaries in Department 20. Right. And then when you're done with that, go to the second question that says display all managers working in 20 and 30 department. Right. Just work on those ones while I'm addressing the concern on the screen. Okay, yeah. You're missing the commas. After every row, you put a comma. So you go back, yeah, right there, put a comma to the next one, comma on this one, yes. And then the last one will have no comma. Yeah.
Oh, okay.
Excellent. And
Oh, what happened? What's going on?
okay, fantastic. Yeah. Before you execute that, can you first of all check if you have data in the department table? First of all, check employee table. Yeah, I think department. You have a select star from department. I saw that. So select star from department. Let's first of all check the department table. Run that one. Let's see. Oh, you have one. Okay, so you're gonna execute the last three you just added. So go back to the insert statement. Yeah, this ones you just built. This one right here. Yeah, just highlight that, insert into that with the three departments. So this will add this three to the one. No, you have to entire insert statement. You have to go all the way. The entire. Keep going. Yeah, right there. Excellent. Now execute.
Execute?
Yes, click on execute. Yeah. Oh, what happened? Insert into this values that. Cannot insert. Oh, okay. You see the error. So 10 already exists. So go ahead and remove 10. That department 10, delete that first row. See,
Remove it?
yeah, remove it. Remove that row. No, the entire row. Delete the entire row and all its information. Accounting, New York. Yeah, delete everything. I want you to understand why we are deleting that, because it's already added to the table. If you want to understand it,
Okay.
right? Yeah, if you look at execute select star from that table, the code just directly below that one. Select star from no, just a moment. I want you to understand what we're doing. Yeah, run that one. Select star from the department table. The department table already have one department. So now you
Okay.
understand why I told you to remove that accounting department. Yeah. So what you're missing now is research, sales, and operation. These three. Excellent. So now run that one. Fantastic. Yeah. So now we have all 4 departments. See that? Excellent. Now let's check out the employee table. Run the select star from employee. Let's check out the employee table before we can proceed to do anything. Yes, to select star from employee. Okay, good news, no data. That's fine. Now, can you maximize your screen so you can check? Yeah, I think your insert statement looks fine. I don't see any errors. Do you see anything that is a concern now? I think everything looks fine. Except the last row. The last row should have no comma. Go to the last row. Yeah, take out that comma. Perfect. And then now highlight everything. The insert. Oh yes, let's go back to the insert statement and execute. Highlight the insert statement for employee. No, you have to everything, not just that one. That one line is not enough. So yeah, right there. Perfect. All the way to that. Excellent. Execute. Column or number of supplied values does not match table definition. Yeah, so you're missing. If you look at closely, something is missing.
Somewhere in all of this, there's something missing. Is that what you're saying?
Yes, a value is missing for a particular column. If you look at the error says column name or number of supplied values does not match the table definition. So can you take us to the top just a little bit? I want to see the insert into what name is the insert into employee. Okay, you're correct. Yes, insert into employee. Then the values. Yeah. So the error. Can you push down Can you do Control arrow on your keyboard so that it gets rid of the output window so that you can see just the code segment? Oh yeah, like that is fine. Yeah. So there's something missing on. Please, can we all look at the Tunde screen so we can identify the. So something is missing. It has to do with one of the values is not stated. So most likely it will be on the commission and salary. So let's look at the first row. First row, that's Smith. Yes, Smith has. So it should be 1, 2, 3, 4, 5, 6, 7, 8. So each row should have 8 values. So Tunde, there's going to be one row which doesn't have up to 8 values, and that's what we are looking for. So each row. So I'm looking at Smith. Smith has 1, 2, 3, 4, 5, 6, 7, 8. Yes, 8 rows, 8 values. Sorry, for Smith. The next row is Allen. Allen has 1, 2, 3, 4, 5, 6, 7, 8. That's correct. The next is Watt. 1, 2, 3, 4, 5, 6, 7, 8. The next is Jones. 1, 2, 3, 4, 5, 6, 7, 8. Yes. The next is Martin. 1, 2, 3, 4, 5, 6, 7, 8. Martin, correct. The next is Blake. 1, 2, 3, 4, 5, 6, 7, 8. That's correct. Clark. 1, 2, 3, 4, 5, 6, 7, 8. Next is Scott. 1, 2, 3. Scott, is that this correct? King. 1, 2, 3, 4, 5, 6, 7, 8. Yes. Turner has 1, 2, 3, 4, 5, 6, 7. I think the error is coming from Turner. Yes, Turner is the error. Highlight the Turner line. So Turner has 1, 2, 3, 4, 5, 6, 7, 8. Oh, that's 8. That's fine. Yeah, 8. That's fine. The next is Adams. 1, 2, 3, 4, 5, 6, 7, 8. Yes. James. 1, 2, 3, 4, 5, 6, 7, 8. Ford. 1, 2, 3, 4, 5, 6, 7, 8. And finally, Miller. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, this looks fine. I don't seem to. Can you do a select star from the
Sir,
table?
I just like hello.
Yeah. Hello. Yeah.
Hello, sir.
Yeah,
Yes,
Lanita.
like if you look at the new, he's not. I don't know if he's not spacing out the new. All the new has not been spaced out.
No, that's fine.
Like
As long as the
it's
comma is
okay.
there. Yeah, that's okay. As long as the comma is there, that's fine.
It's there.
Oh,
Okay.
I'm seeing something on the table. Tunde, can you count the number of columns in your output? When you do a select star from the employee table, count the number of columns in the output window. 1, 2, 3, 4, 5, 6, 7. That's the problem. So you're missing one column in the original structure of the table. You see that? You have 8 values you're supplying, but they're going to 7 columns, not 8 columns. So you're missing something. Can you all check the
This,
requirement?
right?
Oh, just a moment. Yes. Yeah, this definition right here. You're missing one column. You should have 8 columns, not 7. Yeah, go back to that document. You're gonna see the one you're missing. So yes, you have employee number, correct? You have employee name, you have manager. Oh, you're missing job. Yeah. And make sure you put job in the right. That's the third column between name and employee name and manager. Yeah. So job
That's
is
a
gonna be
string.
a string. Yes, just put nvaca 50 and then you make it null. Yeah, nvaca 50, make it null. Put a comma. So what you're gonna do right now, I want you to delete the database you have, because the good news about having this script is that you can delete the database when you have an error and run it again to have a fresh, clean copy. So take us to your management studio on the Object Explorer. Right. First thing you have to do is deactivate the current database. Make sure you point it away from North Star. You cannot delete a database if it's actively in use. So make sure you remove North Star. Sorry, not remove. You go. So on that database, where the database which is currently being used on that block, you have to go there and change it to maybe master database. So this script right here should not be pointed into the North Star database. So change it to a different database. And then once you have that done, you can now right click on North Star. No.
Sorry, where should I go?
Can you go back to the editor? Go back to the editor so that click on, and then go to that white box where you see North Star. that white box before the execute button. There's a white box that reads North Star. Yes, before that button. Yeah, right there. Change that to any database. This is the first step you need to do if you want to delete the database. Make sure it's pointing to, it's not the database you want to delete. You cannot delete the database that is active. Point it to any database. You have to choose anyone except the North Star. Excellent. Now go to North Star, right click and delete. On the Object Explorer window. No. On the Object Explorer window. On the Object Explorer window, find database North Star and then you right click and delete. Towards the bottom. Yeah, I saw it towards the bottom. Yeah. Right there. Now just right click on the name North Star and you see the delete option. And then go to the bottom and click on close existing connection. This is just to close any window if it's using the North Star database. Close the connection and then click on OK. Okay, then now you should be ready to just click on execute. There is a select 17 December 80 on that script, deactivated comment. That one, or you delete it or you just deactivate it. Delete that. Yeah. Now you can submit the entire script. Just click on the execute. Now you want the entire script to run. It still shows a problem with the insert. The insert statement said conflicted with the foreign key. Okay, there's a problem. The insert statement, this is the conflict occurred in North Star, the department table, column department number. So there is one department you're trying to put which does not exist on the table. Go to the last. Oh yeah, right here. Yeah. So one is missing. Yeah. Let me give you the name so that's accounting. So it's department number 10. The name is accounting, and the location is New York. I'm happy you already know the setup, or you see how you're just entering those accurately and put a comma. Yeah, and once you understand that structure, that's it. You see, excellent. No, yeah.
I can't see. Hold on.
Oh, yeah, excellent. Yeah. So we're gonna do the same again. So you have to delete this database, right? So go back to the data box and change North Star to maybe master. The same step you did before. All right, so each time you want to delete the database, make sure you change it on that white box and then you go delete it. The good news is that you have the script. So once you have the script, you can feel free to delete the database. You have to fine tune it until you get it correct. If you already let me know, you can now go click on execute. Once you delete the North Star, the current copy of North Star, delete, right click delete, and then you're now ready to go click on execute.
What can I do with this? Because I'm supposed to.
Oh yeah. So now you're on the editor. You're on the Object Explorer window. You have to go back to the editor. Only when you're on the editor, you click on the editor. Now you can access that. Yeah. So switch it to master or any database, and then go back to North Star and delete. Now you are refreshing. Click on databases folder first, then you refresh. So you are refreshing the entire folder. See, your North Star is not yet showing because you have not refreshed. So click on the database and then you refresh. Yes, and then now expand on database. You'll see. Just wait for it to refresh right there. Excellent. So those who are building databases in the company, these are the steps they go through. You build, you see an error, then delete, and then you keep building until you have it right. And then you save that final copy, which is accurate. You cannot execute because your last location was Object Explorer. You have to come back to, and then now you can click on execute. Excellent. Now you have it right, you see. Now this is the copy you will save. Click on the final save on this so that you preserve the script. You just click on save. Oh, this is the first time you're saving? Okay, just go ahead and put the North Star database script. Locate the folder and then you put North Star database script. So when you're building databases, it has a lot of patience involved, you see. And feel free, as you're building the script, you have an error, delete the one you currently have, run the script, do adjustments until everything works. See, now you save that script. And so this is the end of phase one. Phase one was just to build the database, build the tables and the columns, and then insert the data. So we are done with phase one. So phase two now is problem solving. That's the analytics side. So Tunde, you feel free to close this window, right? And then open a new window. You can now start solving those questions. Yeah, close this window, or if you want to keep it open, that's still fine. But I'd rather prefer you close it so that you don't type anything into it. Yeah. Now you can go to that PDF document. I want you to copy the first question on that PDF document. So we are now going to the second phase, which is the question part. And the first segment will be assignments on operators. So all of this is just testing your knowledge of operators, these first 10 questions in this segment. I think these are easy. It's just back to the where clause, those basics we did on the where clause. Right. Please, I will encourage everyone to solve these questions. Challenge yourself, Right. If you have any challenges, we're gonna do a couple of them. Oh, we have 4 minutes to the end of the class. Yeah, but we should be able. Let's do a couple of them. So Tunde, I'm gonna stay on your screen. I want you to copy the first question. Right. Yeah, question one. Copy that, Control C, and then just put it in a. Now I want. Okay. I wanted you to put it in that block comment environment. Then you can take it to the next line. Make sure. Can you maximize your screen so we don't? Right. And I also encourage you to buy a monitor and project. Yeah. Okay, this looks good. Yeah, I think this is fine. Yeah, it fits on a single window. That's fine. Yeah. So you're already connected to Northwind. That's fine. If when you read this question, you have just 2 tables we've created for this project. Now you have to ask yourself, do you need the 2 tables to solve this question or just one will be fine? This question seems to relate to the employees table. So you first of all do a select star from that table. Okay, yeah, you can just do it. Is the GBO dot yes, right there. So let's go for run this, execute that. So you see, now I want you to identify the 2 conditions in this question and then you put them in the where clause.
Getting excess salary. Okay, so there'll be an and in there too.
Okay, yeah.
Department 20. Okay, and the salary. Okay, square. So you.
Exactly. Yeah, excellent.
Is
So getting this and excess. So that's just a coded word for greater than or equal to.
greater than or equal to. Okay.
Yeah.
Equal to 500.
Excellent.
And yeah.
Excellent.
Yeah.
That's it. Yeah. Perfect. Execute that and let's see how many employees qualify with that 2 condition. Just 1, 2, 3. Excellent. See? Yeah. Everyone is going to solve one question before we leave. I just want you to set that pace. Let's motivate each other. Tomorrow is just going to be problem solving, and then we're going to touch base on other concepts. But please, I don't know if you guys can really spend time and so. Yeah, so Tunde, that's good. Lane, I think you're solving the second one. Let me get to your screen. Lane, you look at the second. Lanita is going to look at third, and then Idris look at the fourth question on the line. So Tunde, that's good. I'm going to leave your screen. All right, so just keep working, keep solving those questions. Tomorrow we're going to continue the process.
All right, thank you.
Excellent. Lane, I'm going to come to your screen. Let's see solution to question 2. So go to the project, get question 2. Let's take a look at it together. So I see you've solved the first one already. Perfect. Perfect. Can you put the second one in the common environment? Excellent. Right there. So, yes, let's look at this one. Display all managers working in this and this department. This is basically one table, right? Just stay on the employees table because the manager column we saw, it was built in the employees table. Right. Excellent. So you just run that first, see the table, and then you build your strategy. Seeing the table in front of you. So there's a manager column. So let me give you some time to look at that. Display all managers working in 20 and 30 department. So you're going to need a where clause. It just basically has one condition, and then you identify those two departments. If you're identifying two values in a given column, two or more values, what operator do you use? If it's one value, like what Tunde used using equality, that if you have two, no, check that's department, working in department 20 and 30. So your where clause is identifying what is built on department number, and then you state a certain operator, and then you bring in those two departments, 20 and 30. Now, the reason why you have the table in front of you is to see the actual column name. Department number is captured department, that abbreviation. So go back and adjust it. That's why the system is giving you an error right there because, yeah. So look at the way, so it's depth number. It's right there. It's even showing on your screen. Yeah, right there. Perfect. Excellent. And now, so if you are interested in two or more values to be displayed in a given column, what operator do you use? You can do it in two ways. You can do equality, just go for in operator. Right, this is a revision. So in operator. So where department number in, and then you open and close your parentheses, and you type in the two values specified. Excellent. This is fantastic. The comma, I was waiting to see that, and then you close it. That's it. If we're looking at department in equal 20, that's just department equal 20, right? So if you run that, you should have just those in department 20 and 30. See, it has filtered, and you're seeing all those 20 and 30. See the output. All right, so display all managers. So they just wanted you to project the managers, and manager is just the manager IDs. So just type, go back and remove the asterisk and just put the column manager. That's what they wanted you to show in that question. See that? Yeah. So now we don't want to show all columns, but we just want to show the manager column. Remove the asterisk and type the manager is captured as MGR. That's the manager column. Now look at the table. Sorry, maybe I misled you. Yeah, that's it right there. Perfect. And now run that. You just have the managers of those departments. Right. Now, are there any repetitions? There are repetitions. Yes, there are repetitions. You don't want any manager's ID to repeat multiple times. What can you do? Can somebody help? What can we do? A distinct. I know that's exactly what you're thinking. That's it. Distinct. There's no need to list a manager's ID multiple times on that list. So if you put the distinct in front of that column, it will go in there and return only the unique occurrences of that. See, remember we've just listed two departments, so the distinct Let's see how, if this thing will give us what we need. How many managers are in charge of two departments? Right, so there are multiple managers, okay, but these outcomes are all distinct. So these are the different managers in charge of those two departments. See that? Right, this is excellent. Right. So Lana, any question from you before I leave your screen? So I'll encourage everyone, please, this is revision, right? You've built that database and the table, you've inserted the data. Right, this is where the analytics go back and solve those questions. They begin easy and they go gradually, they're getting to more interesting topics. So create time and knock off all those questions. Right, that's the goal. Okay. Lanita, I'm going to share your screen. We're going to work on the third question. I want everyone to have a shot on each of these questions, right, so that we set the foundation and you can keep working. You can work as a team and work individually. I just want to make sure that we address all of these questions. Yeah, Lanita, can you maximize your screen? So let me see. What's the third question? The third question is looking at display all managers who don't have. This should rather be employees who don't have a manager. So display all employees who don't have a manager. So that question is supposed to be, so question 3 is supposed to read display all employees who don't have a manager. While we're building this question, while we're building the table, we saw somebody, King. If you go to the employees table, I can see on your screen, if you go to King has no manager. So what would be the condition where manager, that's MGR, is null? Very important. And that's how that question is straightforward. So anyone who has a missing, no, you have to put is null. That's the operator here, is null. So you're looking at only the employees with missing manager. And if your manager is missing, then that is the equivalence of setting that column and putting is null. Now run that one, just highlight and execute and see what happens. It's going to dismiss all those who have managers, and it's going to return only that one employee. You see right there. Why? Because the manager is null. That's why you put is null. This is fantastic. I like this. So Anita does good job. I like this. You see? And once you know this test of nullability, that you're good. It shows up in another project or any other interview, you're good to go. Right. So that's the only employee that is not assigned to a manager. Why? That's the president of the company. You see, the job title says president. Right. And that's how you test for missing column, missing data in a column is null. Right. Yeah, and then we're going to close for today. Let me go to Idris. I'm going to project your screen. Just copy question 4 and let's address it. So Idris, let me share your screen. Right. And this is helping to show you that, hey, these things, it's just create the time and solve them. Right. So Idris, question 4, what does that say? Display all employees who are getting some commission with their designation neither manager nor analyst. I think the question from Lanita, that question was correct. It's the manager. Let me go back just a moment, Idris. I want to go back. I noticed something. So Lanita, I want to go back to your question. We're going to do some adjustments. So this is the original question. I did modify it. This and this are two different stuff. All right, I did modify your question to read this. Display all employees. All right, I want to address something right here. Display all employees. All right, so these two are different. Let me explain something on that. You see that there is a job requirement, there's a job column right here. So if you're solving this question right here, display all managers. This is already a condition. All managers. I want to solve. I did modify your question, but that was something different. All managers means you have to put job. The job of interest should be managers. This is all managers. The first part of the equation. And that's going to be a string. So this will give you all managers. First part. So display all managers. You see, these are all the managers. There are 3 managers. Display all managers don't have a manager. These are managers. Was a manager of this manager is this one right here. And that's when the second condition you place is going to be valid, and manager ID is null. We don't have a manager. Manager ID is null. Oh, sorry, I have to go back on this. Just a moment. Let me explain this. Right. So this right here are the managers of the employees, right? And both employee and managers are placed on the same table. So if, for example, if I ask you who is the manager of Smith, you're going to take this manager ID and look it on this employee number column, 7902. See, the manager, when you are an employee and you become a manager, right, they maintain your employee number, but then it now becomes a manager number. See, so all these numbers you see right here, you can trace them to this, and that's how you get to know the manager of that particular person. Who is the manager of Smith? You have to look up this number on the employee number column, this manager ID. You have to look it up on this side. So 7902, who is 7902? 7902 Ford. Ford is the manager of Smith. Right. Anyway, let's just close for today. I will come back and explain that. That's a part of the table that I needed to explain it. That the manager IDs, you look them up on the employee number. Right. So each person, for example, who is a manager of Jones, you have to take the manager ID of 7839. You look up in the employee. 7839 will correspond to the manager of Jones. 7839. King is the manager of Jones. This is some new information we're going to explore. But let's keep that for tomorrow. We're already above time, right? But that I just want you to understand, and it's going to affect the way we're going to solve these questions, right? So manager, this IDs right here correspond to the employee numbers, right? Once you're a manager and once you're an employee and become a manager, you simply change the column and you put your same employee number now in a manager number. Your employee number becomes a manager number, right? So who is a manager of clerk? You have to look this manager number right here and look up the individual using the employee number 7839. And if you look at every other, it's always going to match 7839. That's you're back to king. So the manager of clerk is king, who also happens to be the president. That's how you build that hierarchy. So I will explain this tomorrow, but just keep working on this. The good thing is that we've been able to build the first phase of the project, which is very critical. Building the database, creating the tables, the columns, defining those constraints, inserting the data, right? And now we can go over this. We are pretty much back to what we did on the select statements, revisions and stuff like that. So you have a lot. And when we get to this, we are also going to build this table. This is a new table you build. This is a skills table. You define. We do it together tomorrow, right? So please keep solving. If you can clear out the 10 questions for the operators, go to the grouping, clear out this. Right, we're going to continue this tomorrow. Right. Okay. See you all tomorrow. Bye, everyone.